This is 20:33 p.m. I've decided to spend my summer to try and share with you what I know. The first time I was learning Python a couple of years ago, I think 5 years now, I used to think it's complex. It used to look like something very difficult to learn. Now I've spent a couple of years in machine learning research, and having looked into machine learning at a very advanced level, I think there's an easier and better way of teaching, and people can actually learn these things even if they don't have that technical background. So I will try to explain machine learning to you in this and subsequent courses, but I feel like I need first to introduce you to programming in Python so that you can become from somebody who has never tried programming to somebody who can actually do complex things in programming. I won't assume that you have done any programming before, and actually you don't need any programming experience to be able to understand what I'm going to say, because I'm going to take you through step by step from the first to the last step. So the only thing you need to do is you need to be able to use a computer, and you need good internet access. If you have those two, then of course now you're good to learn. So we have 16 stages here, and currently you are at the beginning, so you have covered 0% of this course. And now I'm going to take you through each step, one after the other, and each leads to the next. You're going to begin with installing Anaconda. So if any of you have never worked with Anaconda or anything, you're going to be very okay. So you don't need to worry. Then I will guide you through every single thing. The only thing you need to understand about these stages is one stage leads to the next, and then it leads to the next. So in short, they are compiling. They are like a step from one point to another. And these are going to guide you so that in case you've never seen any of this information before, you are not going to struggle. Once you reach the final point, you're going to find your first analytics project where you're going to put all these things into practice. Now that we have already talked about this, how about we go ahead and install Anaconda and then start getting things done? So first things first, we are going to go to Google Chrome or whichever browser that you are using, and then you're going to type anaconda.com, because this is where we are going to download this app from. And then you will click enter, and now you're going to come to this site. You're going to pick this first one here because you want to check that carefully. So once you click here, you're going to come to this page where you'll find information about how you're going to, everything about Anaconda and stuff. But now I've seen this before. If you want to read it, you can read it, but I will proceed to download. So that's where you need to be. Click free download. You are going to be directed to this part here. And this part is where now you need to click get started. However, before you download, the first thing you need to do is to create an account. There are a couple of options, and the only thing you need is an email address or a Microsoft account or a GitHub account. So you can use two options. The first option is you're going to sign up manually. So you click here. And when you're going to do that, it means you're going to enter your details manually one by one. If you are signed in with your Google account, you can click here and you can proceed. And this is the option that I will use, and I will show you how to do it step by step. You can also click here for Microsoft account and here for GitHub. But now let's get back to the Google account. So I'll click here, and it's going to take me to this page where I need to choose the account that I want to sign in with. If you have multiple accounts, of course, they're going to show here. But now, in my case, I have only one account, and make sure this account is signed in. So I'll click that. Then we can now proceed to the download part. There are a couple of options for different people because there are different types of operating systems out there and PCs. So in this case, I'm using a Windows PC. So I'm going to install Anaconda for Windows. But you might be having a Mac or maybe a Linux, and you are going to have to check that before you proceed to download. But in this case, I'll just come back here to Windows and select that. Now it is going to start downloading the file. And you can actually track the progress up here. So as you can see, it is showing me I have, that's 2 minutes. Yeah, so I will wait for those 2 minutes, and now I think it's done. So once it's done, I will click here to install. So for you, just click there. And then, of course, I will minimize this browser because we don't need it anymore. And now here we go. That is, yeah. So this is the first page for us to now install. You're going to click down here. It is written next. I hope you can see that. So you're going to bring your cursor all through here and then click here. And here we have a couple of license agreement. If you have the time, you can read. But honestly, so just, I'm going to agree. And it's going to ask you if this is for you or all users on your PC. If it's just you using one PC and there's one account, you can click there. Otherwise, if you have other users, you can make it accessible to all the others. So I will choose just me and then next. This is a path where Anaconda is going to be saved and where everything else is going to work from. And you can change that by just clicking on that and then, yeah. So I think you can follow through this, but I don't need to change. So I will collapse it and then click next. At this stage, you're going to be asked, do you want to create the shortcuts? Yes, I need the shortcuts. So I will install with the shortcuts right here. And yeah, that's the installation process. But this one takes some time depending on the speed of your PC. And you're going to have to be patient. Once it's done, you will simply come down here and then click next. And yeah, so you have Anaconda on your PC. So you're going to click next, and I will uncheck these two because I don't think I need that at the moment. Then after that, I will click finish. Yeah, and now Anaconda is on our PC. Now I want to create a shortcut, and this is not part of the installation process. I'll right click, pin to taskbar, so it's down here. And now every time I will be clicking right there, and I can always access Anaconda. Now, we have this, and now we can proceed to sign in, which is just simple. Click sign in. So let's write our first Python code. To do that, we need to open our notebook. So under the taskbar, you will click this icon here called Anaconda Navigator. And it's going to open a couple of applications. Now, what we are going to use in this exercise is what we call Jupyter Notebook. And when we scroll down, you will find Jupyter Notebook right here. So you will click under Launch. And now, once this is launched, this is where we are going to start writing our code. So it's going to send us directly to the web. And what comes to your screen is exactly what you're seeing here. Now, we need to write our first Python code. To do that, we are going to click on New and Python 3. If, for example, you already have another Python code that you want to open instead of creating a new one, so you will click Upload and you're going to search this in your PC. But since I assume this is your first time, so let's click on New and click on Python 3. So it is going to open this Jupyter Notebook. So what you are seeing is exactly where we are going to write our Python codes. So this one here is called a cell. And you can add more cells by simply clicking right here, and you have another extra cell coming down here. When a cell looks like this and it is written code up here, it means you can write your code in this cell, and when you run that code, it is going to execute. So for example, let's write our first Python code. Write the function print. So make sure that is going to come out as green, and then enter an opening bracket and double quote or a single quote, whichever you choose. You can use either of the two, and then write the management. And then once you have written that, you're going to add another double quote if you used a double quote here, or a single quote if you used a single quote here, and then close the bracket. And now you can come up here and click this icon here, this is where we run the cell. So when you click, it is going to write the management diary down here. So instead of using the double quote, you can also use the single quote. For example, you can do exactly the same thing by simply typing print . So you can see here we have a double quote and here we have a single quote. And when we run this cell, it is going to give us exactly the same thing. So this is called a string, and we are going to discuss more about that when we reach under the data types section. But besides writing a code, you can also input text that you're not going to output in these cells. So for instance, I said if you want to add a new cell, you're going to click up here. So I can add a couple of cells. And now I want to add a text here that is not going to be code. So I will come up here and click on this drop down arrow and select Markdown. So when now I've selected Markdown, I will type something. For example, please I have written, please subscribe to this YouTube channel. Then, if I want now to execute this, I can simply click up here, run, and now this is going to be as a text, but this is actually not a code as this. You can also, for example, leave this in bold. If we want to put this text in bold, you'll simply click here, Markdown, and then after that, you can add these 2 stars, then write exactly the same thing. And add the 2 asterisks, and that would be in bold. If, for example, you want to have this in italics, you can come here and click on this cell after selecting this as Markdown, and then put the single asterisk. Then you can write another piece of text, for example, thank you for subscribing. And then you can run. Now, congratulations, you have written your first Python code. And in future, when, for example, you are writing your code and you want to leave some information, some notes, some text, then this is how you can be organizing your work. But then, we have not saved this file and renamed it. So what you will need to do is, you will come up here and click on this icon. This is the save icon. So when you click here, it is always going to save. But then before we do that, we need to rename this Jupyter notebook first. So under this untitled, this is the name. And you can also see this one here, untitled.ipynb. So every other time you see ipynb, it means it is a Python notebook. So what you are going to do is you are going to click right here and rename this to something, say alpha. So our notebook is now called Alpha. To know that it has been renamed as Alpha, you can always come back here and check if it was renamed. Right now, it is written Untitled. But when you refresh, now it is going to change from Untitled to something else, which in this case is Alpha. Now, you might be having a lot of notebooks. How do you know which notebook is active or which one is running? Up here, you can click on running and you can find that alpha is actually the one that is running. But then you can also use this green icon to actually see that it is the one that is running. Now, this is the basic that you need to write your first Python code. But then we don't understand everything that we do have here. This icon here is a save icon. So every time you write a code and you want to save it, you will click here, save, and that would have been saved. Then, if you want to add an extra cell, you're going to click this plus. So it is going to add a new cell. Alternatively, you can use right here, you have a plus. So this means there's a cell below or cell above. This one here is going to cut a cell. for instance, we have this cell here and we want to cut this cell and paste it elsewhere. So we will click on this. And then once it's cut, you can come and click, let's say here, and you have this part here, it's going to paste. So we have moved it from up there down here. Alternatively, you can copy a cell instead of cutting. So instead, for example, you want this to remain here, but you also want to have it as it is. Say I want to add an extra cell here. So I will copy this to copy. Now that I've clicked here, I will click on copy. This part here is for copying. And then I will bring the cursor somewhere down here and then I will paste. So this has stayed on the notebook. As you had already noticed earlier, this is just text at the moment. And now if we want to execute this line, we are going to click this icon here. And this icon is going to run that cell and now it's going to be executed. Every time a cell is run, you will be seeing this number here. So this one has been successfully run because this is 4. But this one has not been successfully run. So if you want to run this again, you will bring your cursor here and then you're going to click on this run and now it is 5. So the management diary. Suppose you have written a very long code, and we will do this when we get to the deep learning and machine learning phase where this code executes for a very long time and you want to interrupt or stop the execution. You're going to use this part here to stop or interrupt the execution. So that simply means this kernel. So in most people who are now used to this work, they're going to call this a kernel. So it is going to stop running when you click this icon here. And if you want to repeat or restart the kernel, so for example, I want to do this all over again, I will simply click here and the kernel will restart. Now it's going to ask, then I will restart. But then sometimes you can write a code in several cells, or for example, you want to execute all the cells simultaneously. Instead of using this, you can bring your cursor up here and now you're going to use this double part. So this one is going to restart the kernel and run all the cells that appear. So from this first one to this last one down here. So if I click on this, you will see now it will ask me if I want to restart the kernel and I say restart. Now these ones will run all through from the first one to the last one. Up here, you have other alternative things that you can use, but most of the things that are here are actually a repetition of what you will need to use down here. So for example, if you want to change this kernel, this notebook to be in dark mode, you will click on settings, and under settings, you will have theme. And now you can see the theme is light, but we can change this to dark mode. Ooh, there we go. Now that is the dark mode. But then I would just like us to stick with the light mode for now. So I'll come back to settings and then under theme, I'll come back and click on light. So we have our light mode as you can see it on the screen. Those are the most important basics. Before we start doing more interesting things, we need to understand what we are going to work with. So there's something called variables, and I would like us to look into variables in a short while before we can begin. But before we talk about variables, when you want to run cells in Python, there's something called a comment, and you can always leave a comment using this hash where you can write something like a string. And this means that every time you're going to run this, it is going to be ignored. So for example, if I put this here and then I'm going to run like test, then it is only going to run the second one. Now, assume you have a rectangle and you want to calculate the area of a rectangle. To calculate the area of a rectangle, you're going to use length times width. So you have a rectangle with the length 10 and a width 15. So that is going to be 10 multiplied by 15, you're going to get 150. You can always do any mathematical operations in Python, and that is going to be a simple thing, but we are going to come back to that way later. But then, now let's assume you have 50, 60, 70 rectangles, and you want to calculate the area for each. So instead of always coming back to type this one here, you can define this as a variable. So what we usually call a variable is something whose value keeps changing. For example, if you define L as equal to 10 and W as equal to 15, now when we run this cell and we run this cell here and come down here and assign, so when we are going to run L, we are going to get the value of L is now going to be 10. Python is clever in the sense that every time you assign a variable, it is going to identify what type of a variable that is. For example, L is a letter, but now when we input L down here, it becomes a number, 10. When we want to calculate the area of a rectangle, it's going to be length multiplied by width. And now that is going to be 150. It is exactly the same thing up here. Now, if we change this, for example, to 20 and run this cell, then we are going to have 300 here. Now, there's one thing that you need to know. Running the cells usually captures the information in a chronological order. If we have L here as 20 and W here as 15, now if we had another, for example, L down here, and I want to assign this value, in this time I'm going to assign this value as 25, and then I will run this. Now, when I calculate the area of a circle, it is going to be 375. But this is not the same as this. So 20 multiplied by 15 is supposed to be 300. So what usually happens is the last cell that we ran with the value L is going to store L as 25. So it is going to override anything that was previously saved. So you need to be very careful with the order in which you are assigning your variables. Another thing, this language is case sensitive. What do we mean? If, for example, you have a letter A and you assign it the value 11, and you have another uppercase A and you assign it the value 15, they are not the same thing. So it means A assigned the value 11 is going to output A. But then if we put capital A here, it's going to give us what? An error, because we have not defined A yet. So this A and this A are two different things. So if we want to define this A clearly, then we have to run this cell here because it contains an A. And now we can come back here and now we have our value as 15. So it means the value of A, the lowercase a, is 11 and the value of the uppercase A is 15. So if I want to calculate the area of a rectangle with length A and with capital A, I'm going to multiply the two and I'm going to find this value. It is not just with numbers, you can also assign values with text. And you can see here, in that case, you are going to have to input your double quote, and now we are going to have L as the name here, and you can see it has the string. For example, if I assigned L and I did not input the double quotes, then this is going to give us an error. Why? Because this one here is going to be seen as a variable and we have not defined a variable called name anywhere. So to make this a string, we're going to add either a single quote or a double quote, and then now we are going to have L assigned the new value. But then we said Python is clever, but then how many data types do we have? We have only seen two. We have this number and we have this text, but there are many other data types. So think about data types as the way in which the machine will understand what that letter means. So we have different data types, and here we're going to talk about around 7. We can have numeric data types, you can have text data types, you can have sequence data types, Boolean, and we are going to talk about each very briefly. But let's begin with the simple one, the text data type. So a text data type simply stores textual information and it is going to be assigned strings. So when we say, for example, your name is Alex and you want to save that into a variable, so we are going to have a variable here where we are going to input your name, and each string variable is going to have double quotes. Now, for example, this one here is going to be seen as a string. Why? Because it has double quotes. So if I run this B, and to check the data type, the only thing you need to do is type this word. The only thing that you need to do is to type this word and then enter the name of the variable and run. So here you can see it is written string. But up here, if I run this cell and then I want to see the data type of this variable, which is letter A, then that is going to be an integer data type. Why? Because it has been assigned using a double quote. So a string simply stores textual data or numeric data that is actually quoted within a text. And you can also store every other thing like special characters and stuff, but it has to be within double quotes. Then we also have the types of numbers. Okay, in this context. So we have an integer, a whole number, like how many are you in that room? If you're one person, it's just one. You can't be 1.5. Even if you're pregnant, I think you can't be 1.5. Yeah. So it's either you're one or two people or three or four. That is the numeric data type. People, animals, cars. So it is assigned the value, a whole number value. So that is going to be called an integer data type, and it's simply going to be assigned as this. As I said, these data types are usually easy for you to assign because Python will always identify them. Then there's a second one called a float. A float simply contains a decimal point, like your age is 25.5 years old. And now when you run this cell and then check the type, it's going to tell you this is a float. And there are a lot of types of floats, but we are not going there. Then there's also a complex number. For example, what is the square root of -6? So that is going to contain some element of a number, which is a floating point, I think. Then the other one is going to be a complex number. So we are interested in the complex part, but we are not going to use that in this case. And it's very rare that we are going to use it anywhere, actually. So it is usually assigned a number like 2, like 9, like 91, or 915, but at the end you're going to have to put a letter J. So when you input, every time you assign a variable and you input the letter J, it is going to be understood as a complex number. And now when we check this type here, it's always written as complex. There's also something called Boolean data types. So Booleans are usually used for conditional logic and switches. So we'll come to talk about that in a short while, but it's simply assigned true or false. Are you subscribed to the management diary? If it's yes, then it's true. If it's no, then it is false. So that means it is a Boolean data type, true or false, and I hope it is true. Now, you can assign that using this word true, but with the first letter being uppercase. Now, every time you see a word with this different color, in this case I can see it is green, that is what we call a keyword. So keywords are words that you should never be using to assign your variables. So if you call a variable, for example, true is equals to 61, so every other time this code is going to create some confusion because true means something else in Python. Now, if we run this, then it means X is going to be true and the data type is Boolean, and then another option you can have it as false, which is also Boolean. Secondly, we have the binary data type for dealing with raw data bytes, and this is going to be things like images, files, or network packets. But as for now, you only need to understand this exists. You are going to meet it a couple of times, but very rarely. Actually, if I get to think about it, I don't get to meet it quite often. But there are three types. So there can be bytes, byte arrays, and memory view. And this is how they are assigned. So this is for bytes. For byte arrays, you have to assign it with the keyword byte array. And finally, for memory view is you're going to have to assign with the keyword memory view. Now, the difference here comes in bytes are usually unchangeable sequence of numbers. So, sequence of bytes. And then when we come to byte array, these ones, you can actually change them. But for memory view, Python allows you to code to access the internal data of the object, so without actually having to copy it. So that is where now we get to use the memory view. But when we will get to need it in future, we'll always come back to talk about it. Now, this further part is more interesting. The sets are going to be something you meet very, very frequently. A set is usually assigned using curly braces. If you look up here, everything has been using these brackets. But now we are using curly braces. So every time you use a curly brace in Python, you are going to, there's somewhere else we're going to omit it, but in this case now, in the first one is going to be a set. If we run this and we check the type, these are types of phones, this is an iPhone, Samsung, and Google Pixel, then it is going to give me, this is a set. But let's say you are entering your data and you found, for example, that this set has, let's say, a repetition of numbers like G. So the Google Pixel was repeated. It is going to have to remove this first one here and actually save only the unique identifiers. So G, I, and S. This is going to be very important. For example, you want to calculate how many unique instances do we have in a data type? How many unique instances do we have in a certain array? So you are going to have to assign it as a set, and then it is always going to collapse everything, and now you can count the size of elements of a set. Another way you can use curly braces, so you see here a set uses curly braces, but there's also under maps or mapping. And mapping simply means if you want to define a user, you can, for example, have the name, and I want you to just look at the syntax. Syntax is how the code is written. So here, this is the variable, then this is the name, this is the variable, and then this is the value of the variable. And you can have different data types within a dictionary. So this type here is called a dictionary. If we run this and then now we check the data type, it's actually written as dict. So this is going to be dictionary. Another type is sequence. So sequence, there are 3 types of sequences. So we can have a list, a tuple, a tuple, and then you can also have a range. So a list is simply something that you can slice and you can change it. So we have this list containing names of fruits. So we have apple, banana, and apple. So if you run this and then you check the type, it is apple. But then if we check, for example, the fruits, you see apple has been repeated. The apple has been repeated twice. But here under sets, as I mentioned, it is going to expunge any repetition, so you're going to have unique identifiers. So I hope that helps you remember that we have something else that looks nearly close to a set, but it's different, and it's called a list. A list is usually assigned using these brackets. We also have a tuple. A tuple, once you have assigned the value, you cannot change it. So that is the key difference, and you can see that it's usually assigned using these brackets. And finally, the range. So if you want, for example, to define numbers that follow a certain sequence, say numbers from 1, 2, 3 up to number 600, why on earth would you want to waste your time writing 1, 2, 3 to 100? You can use a sequence as a function, so a range, to define that sequence. So simply write the keyword range, open a bracket, and then write the first number that you want to appear in that range, and then the last number that you want to appear in that range. And now it is going to give you this sequence of numbers. And you can see here, it actually shows you 1, 3. Then how do you know what numbers are contained in this range? You are going to use something we call a for loop, and we are going to come into that later. And when we run this, it's going to tell you now this range contains the number 1 and 2. But you don't need always to define where the range starts. For example, you can just write this, and now we can have, let's say, 23. So this means it is going to begin from wherever those numbers usually begin up to number 23. And now when we run this and now check all through, it's still a range. And now the sequence is going to write from 0 to 23 because Python usually begins counting from 0. And now when we check the numbers that are here, they're going to be 0 through 22 because 23 is going to be excluded. Again, you can show something we call step. Step simply means I want you to generate numbers from number 11 to number 23. So 11 here means start from number 11, stop before number 23. So that's going to be number 22. But now you can also define how many steps it's going to take. For example, after every 3 numbers. So when you run this and now check, it's still a range, but the sequence is now going to change. So it is first number is 11. The last number is going to be 23, but it's going to be in steps of 3. And now when you check those numbers, it's 11, 14, 17, and 20. In future, you will notice that data will exist in different data types, and you don't need to be entering or inputting the data every other day. You can change one data type to another. And here is an example. Let's say you have a variable called x and it is assigned these fruits. So if we run this cell and check what data type this is, we can find that this is a tuple, and we have actually discussed that already up there, how tuples are defined. But then we don't want to work with a tuple, we want to work with a set. So the only thing you need to do, as I said, this is a keyword. So you can change this tuple to a set by simply assigning a different variable or still the same variable and then use the keyword set. So for example, you're going to write y and then assign the set x, and x is what we already have here. Then now it is going to be, this is a set. And if you are not satisfied, you can always check that this is actually a set. Also, you can define that as a list. For example, you want a list containing all the data in the set y. So you're going to use the keyword list and then now assign y. And then you can always run this. And now you will have type z is going to be list. So this is how you can change one data type to another. Now that we know how to output text and we also know something about data types, we now need to understand how you can input your own data. For example, sometimes you want to take input from somebody and you don't know the exact value. So what you will do is you will need to assign or accept an input from a user. So this part is going to guide you through how to accept user input, and then we will get to talk about operators which are going to be used to manipulate numbers, text, and data. So to begin with, let's look at how you're going to accept an input of a string or a text. So for example, you want to input your name. So you're going to ask somebody, input your name. Anything that actually appears within these double quotes can be changed. So this one, for example, you can just ask for name as it is. But then because we want this text to be readable, we add some space so that it will begin after this space. So if you run this, now you are going to have to see this part here, name. So you're going to enter your name. So that is, for example, my name is Omae, and then when you run, it comes out as a string. But if now we want it in whole, we can just say input, enter your name. So when we run this, it is going to ask you to enter your name, and that is going to be Omae. And then when we run, now this is going to be Omae. But now the question is, how then can you use this name later? So what you need to do, you need to assign a variable. We have already talked about how you're going to define a variable, but then, for example, if we want now to call this variable name, then you just write the variable name, and then you're going to use the assignment operator. We're going to talk about operators shortly, that is the equal sign. But then after that, now you're going to ask the user to input. Now, when we run this, it is going to ask you to enter the name, and now you can enter your name here. The name is the management diary. Then when we run this, now it is going to output this question and what we've just entered. But the output itself, as in this case, it is not provided. If we want to see how we have stored, what we have stored in this variable, then we have to call that variable here, and then we are going to have now the name as the management diary. Now, the question is, what data type do we have here? This is going to be a string data type. So if you want to prove that, you're going to have to run that. And now you can see that the input has come out as string. And we are going to see why this is important in a short while. Now, going back to our example of the area of a rectangle, I would like us to ask the user to input the length and the width of the rectangle. So, for example, you're asking the user enter the length of the rectangle. Now, if we run this, it's say, for example, you're going to say the length of the rectangle is 25. Now, if you want to ask for the width, you will repeat the same. And then when we run this, you're going to get the width. Let's say it is 30. If now we come down here and call length and width, then we are going to find, for example, our length is that 25 and our width is 30. Now, how can we calculate the area? We already said area is equal to length times width. So I would like to show you something here. If we run this, what do we get? This is an error. Why is this an error? I said, if you see this output here, it is in double quotes. So it means it is in string format. So the data type here is in string format. So if we want to check that, we can see that it is actually string, but you cannot multiply strings. So what you will need to do is you will have to change the data type from string to integer. And I think we talked about that before we actually started this section. If you did not get it well, maybe you may want to go back there and check so that you can get the whole picture. So if we try now to change length into integer, then we are going to have now our new data type, that is length, is going to be 25, which is actually different from what we have up here. So if we check the data type for the length, then it's going to be integer. Now we can repeat this for every other variables that we have. And going back to our example up there, so it means we can change the type of length to integer. But now the problem is you actually won't be needing to, every other day you want to ask the user to input the value first, then you are going to change that value into any data type that you want. If you are sure that width should be an integer and length should be an integer, instead of it outputting or storing the value in the variable as a string, you can actually assign it directly while you are writing your code. As you will notice, and in future you will notice, that writing efficient codes is one of the key things that you need to understand while you're trying to get your work done. So, for example, we could have assigned width specifically using the defined data type. So one of the data type that we usually talked about up there when we were talking about numerical data types, we said we have an integer data type and we also have a float data type. An integer is a whole number. A float contains a decimal. So if, for example, I assign width as a float data type and I say my width is 10, it's actually going to be stored as 10.0. So that is because we have defined this as a float data type. But now if I change this to int, then it means it is going to have to be stored just as an integer. So we have now our two data types as integer. The first one is the length and the second one is the width. Now we can proceed to calculate the area of a rectangle. As we said, that is length multiplied by width, and that is going to give us 250. But then this is also not stored. For example, this is not stored in any variable. So we can define a variable called area, and then we assign this value so that when every other time we calculate the area, we can just assign the formula, assign the values, and then we can call this. We can also use the print function. Print, we said print usually outputs a certain value that has already been stored or a text that we want to output. So if, for example, we want to use print and then we call this variable area, here, as you can see, it is not in double quotes, so it means this is a variable. But if we added this quote here, then this is no longer a variable, but rather it is a string. So for example, if I run this, it is going to print this word because we defined this as a string. But now if we define this as a variable, then it means if I run this, now it is going to give us this value of 250. Now, the user or somebody who is on the other side would wonder what actually is 250. So You may want to output this as a complete statement, as a sentence, so that whoever is using this can understand that you're actually talking about the area. How do you do that? So you're going to simply write print, then this string contains information about what you're trying to output, and finally you're going now to call this as a variable. So when we print this, it's going to tell you the area of the rectangle is 250. But is this the most efficient way to write your code? Definitely not, because we have a lot of repetition. We have a lot of things that we could have actually done away with. And I can't blame you, or nobody's going to blame you if this happens to you at this level. But now as you advance, you're going to have to learn more efficient ways to write your code. And one way you could do that is using this list. So for example, you can accept a lot of inputs. So we want length and width input simultaneously. And this can be done by simply accepting an input, but you're going to have to split. So when you run this, now you will enter the length. For example, we said it is 10, but now you will have to add space and your width will be like 20. So it means this first one here defined as length, the second one is defined as width. So when you run this, you're going to get this output. Now the only problem is that these values are actually in string format. So it means if you want to output an area, because you cannot multiply two strings, you are going to have to change the data type at the implementation stage where you're calculating your area, and that is simply going to be area is equal to integer. Now you're going to change this data type from string to integer. So when we run this now, we have now our new function here, the area, as 200. Now we can output this as a complete statement, and this is going to be a statement containing information about the length and the width. And now, as you can see here, you already see that the area of a rectangle with this length, so this is a string, and then we leave some space. Then after that, we are going to assign the value of the length that we actually input up here. Then we are also going to assign the value of width that we actually input up here. Then this text is what we are going to see on the screen. You need to be very careful because we have here double quote, then a text, then double quote, then after that we have a comma. Then we can now put the variable name. So we said the variable is something like the length. Then after that again we do a comma, and then we start a double quote, from which now we are going to have another string. So when we run this, this is what you have. The area for a rectangle with the length 10 and width 20 is 200. Again, is this the best way to write? No. So this, when you write this, somebody is actually going to know you're actually getting started. One alternative you can use is using an F string. So this is one clever way to do it. So it means you're going to do like print, then use the F string, the total area of a rectangle is, then you're going to assign it as it is. So when we run this, it does give us exactly the same thing that we got up here. Sorry, right here. So this one here is called an F string. So that is one way you can learn to output your results. As we have noticed, this one here is going to output this value, but we may want this value to be output as a list. So how do you do that? Of course, you can just use this list keyword here. So this one creates a list. And again, we talked about lists under the data type. So instead of you having to define this data type later as the integer, because here you actually got the data type out first, then after that you had to come and change it to integer because it was a string. You can define it within the call function. So when you're writing a code that is going to accept the input, everything will be defined in one code. So in short, now that is going to, when you run this, you're going to have to enter those values the same way we just did. For example, the length is 10, space, and your width is 20. Now, when you run this, you're going to get a list. And this is what we call a list. We already talked about lists. But then, how do you access, for example, something like the length? Now, given this list, then we can assign we know this first value here is the length, and we know this second value here is the width. So we can actually assign that the name length and width, because this so far does not have a name. And this here is going to show you how you're going to access. So I said Python begins counting from 0. So when you write like this, you're actually telling the computer or the code to understand it as follows. This length and width is the name that you defined for your input up here. Then you're going to tell it, so this thing here that you have, this list, is what is called, the PC understands it as this. So what you're going to do now is you're going to tell it, I want to access the first value. The first value is 10, but it doesn't begin from 1, it begins from 0. So you're going to have to begin counting from 0. So this statement, in a layman language, it means access the list containing 10 and 20, but then from this list output only the first value. And this first value is going to be called length. So if you run this, and now we ask what is our length, so it is going to be 10. And this 10 is an integer because we already defined up here the output to be an integer. You might find this a little bit confusing for now. So I'll take you back here and give you now an easier and more straightforward way to do it. So you're going to ask the user to enter an input, to enter the length, to enter the width. If you write this code, this is what this code does in simple terms. It is asking you to enter the length and width. So how you're going to do that is you're going to enter a value and then add space, then add another value. Then after that, it takes those two values and converts them from string to integer. So that is what we have here. So it converts them from string to integer. Then after it has converted them from string to integer, it multiplies them and then assigns them to a variable called area. So from this point onwards, area means integer length multiplied by the integer width. Then after that, now we can output our results. And how do we output our results? We can just say print the area of the rectangle with length. Then we call this function here length and width. Then it's going to take the value of width. And then finally, this is a string, and then it's going to output the area. Now, we're going to enter 10 for your length, then add space, then width, let's say it is 56. Now, we have all the values that we need. Then you're going to click enter, or run in short. Then after that, it's going to do the calculation for you and then tell you the area for a rectangle with the length 10 and width 56 is 560. Now, write a simple code of something like you're going to ask somebody to enter their age and then to also enter their level of education. And then after that, it's going to output you are X years old and you have studied up to level X. I hope that is simple. In this part, I would like us to talk about operators. So we have already talked about calculating the area of a rectangle, but you have seen me use things like equal sign. You have seen me use things like asterisks for multiplication. So all these things are called operators. And we have different types of operators. Here, I'm going to take you through 7. So we have arithmetic operators, assignment operators, logical operators, comparison operators, membership, identity, and bitwise. But there are a couple others. Now, arithmetic operators is what actually most of you are used to. But before we talk about operators, there's something very basic in mathematics, and I hope that you've seen or heard this, called BODMAS. And BODMAS is actually going to apply here. So in short, it's called precedence, which operator comes before which others. So the BODMAS thing, as usual, it's brackets, orders, division, multiplication, addition, and subtraction. And if you don't remember how that used to work, you may want to go somewhere and check and then come back. This is going to apply also in operators. Okay, you have probably met this kind of comment for the first time. So there are two types of comments. One, you're going to use this 3 quotes. So this one is what we call a multi-line comment. So it means when I write this, I can use these 3 quotes and then write a lot of things in so many lines. Then after that, when I close with this one, so it means that everything that is in this line, it's a comment. For example, if I came up here for the code that we had written and put this as with 3 quotes and then do the same down here, then it means now this is not a code anymore, but rather it is a comment. And I said comments are usually ignored. So if we run this, you see, now it writes something completely different. In short, it tells us what is in that comment. But if we eliminate this, now we are going to have back our code. And this is what we can run. And then we say 10, we say 56. And then when you run that, you get your entire code. The other type of a comment, of course, we said is the single line comment. So you always use these comments to make your work easy, clean, and readable. I can come here and I say, I want this code to be associated with using BODMAS in Python. So it means this one is a comment and it's going to be ignored, and this is a multi-line comment, it's also going to be ignored. And wherever there's an hash, that means it's a single line comment. Now let's talk about operators. So there are different types of operators as I said, and now I want us to look at the first one, which is the arithmetic operator. You have already seen some arithmetic operators before. For example, when we were calculating the area of a rectangle, we said length multiplied by width. So that is an arithmetic operator, and that one is for multiplication. Now, here, I'm going to put this comment here, and now at least I can now try to show you each operator as it looks. Addition is simply the plus that is on your PC. So let's define 2 variables, x and y. So x, we have assigned it the value 10, and y, we have assigned it the value 7. So for the addition operator, it's simply going to be x plus y. And that is going to be, so we have actually not run this cell. So I'm going to run this, and then when I run this now, it's going to be 17. The second one is the subtraction, and it's going to be the minus, the normal minus symbol. So when we say x minus y, then that is going to be 3. So I think that is easy. Then multiplication is an asterisk. Multiplication is now going to be x multiplied by y, and now that is going to be 70. Another option is division. Division is simply going to be that. So when you want to divide, you're simply going to change, for example here, you're going to change this to this. And now when you run, you're going to get this floating number, 1.428 blah, blah, blah. Then when you want to do a modulus, now what is a modulus? I want you to see this. Probably you're meeting this for the first time. So when you want to write percentage, you use this symbol. But now here it does not mean percentage. It means modulus. So if I say x modulo y, it means, for example, if we changed this to 4 and run that, we are going to get 2.5. Then if now we get the modulus, it's going to be 2, because the highest number close to 10 that 4 can divide is 8. Anything that remains is going to go into the decimal part. But then we also have something else called the floor division. So the floor division, you're going to use these double lines. I want you to understand it as this. If we have 10, how many times does 4 go into 10 without any extra remainder? So it is going to be twice. If we say 3, so how many times does 3 get into 10 before we start having decimals? It is going to be thrice. And you can actually see that if we run that here and we run that here, then it's actually going to be thrice. So we can also take another number like 6. How many times does 6 get into 10? It is going to be only once. So this whole number 1 is called the floor division. So if we were to run the floor division and say this is our number, that is 10, when we divide, we are going to get 3. You can already guess the modulus for this is going to be 1 because the highest number that can be divided by 3 is 9. So what remains from 10? After you have removed 9, it is going to be 1. Now, that 9 that you removed, if you divide that number by 3, you're going to get, for example, so when we run this, the modulus is 1. That 9 that remained, if you divide it by 3, so you're going to use here this double line, and then you're going to get 3. The other part is going to be the exponentiation. Exponentiation is simply what most people call the power, and you can use this 2 asterisks. So multiplication is 1, exponentiation is 2. So for example, if you want to write 2 cube, so that is 2 times 2 times 2 is going to be 8. If you want to write 2 squared, then it's going to be 2 times 2, which is the same as 4. If you want to write now a very big number, like 2 raised to power 1000, then you can actually get that number here. Oh, that's quite a big number. You'll tell me if you know the name. The next type of operators are called assignment operators. So an assignment operator simply means you're going to assign a value. And I think you've already seen this. When we said area length multiplied by width, you have actually already used an assignment operator, and this is, let's say, the mother of all assignment operators, and you should not confuse it with an equal sign. So this can be read as we assign length times width, the variable name area. This does actually not mean that area is equal to length times width. You need to be very careful because that's how Python is going to understand your code. But there are other types of assignment operators. And all of them are going to actually, as you can see now, all of them are going to depend more or less on what we have called the arithmetic operators. For example, you want to output a range of numbers. Let's say to 11. So what you're going to do is you're going to define a variable, let's say val, and call the function range, and say I want the value 1 and I also want it to output up to number 10, so we are going to exceed by 1. Now when we run this, it is going to store these numbers, and you can have this as range 1 through 11. We can actually see that range here. So for example, if we use the for loop to output all these numbers, we have number 1 through 10. So this is 1, and then the next number increases the previous number by 1. So we could have actually written this in another alternative way by defining val is equal to 0. Okay? Then we could say val is equal to 0 plus 1. So when we want now to output the value val, so when we run this and we run this, we are going to get this value 1. So it means the first number that we had was 0. Now we have increased it by 1. That is not an efficient way to do it. But anyway, I hope you get the idea. So one way you could do it is you can use an assignment operator. So there are various assignment operators. For example, ones for increasing, ones for decreasing, ones for dividing, ones for outputting the modulars and stuff. So if I wanted to increase, I could simply say val, instead of having to write, because we have already known now our val is 1, now I could just say plus equal val. Plus equal 1. So increase it by 1. So when we run this and now we want to see what is the new value of val, now we are going to get that as 2. Then we want to get it another extra one, that's going to be 3. When we want to another one, it's going to be 4. So that is how you are going to input it. Another one is a decrement. Instead of increasing, you could have actually wanted to reduce 1. So you use a negative sign, so a minus. So that one you're going to get val, so that is 3. So other types can include like an asterisk. So this means the value of, so this is 3, then you're going to raise it, let's say by 2, that is the square. Now when we test, we are going to get that as 6. Another one is going to be like division. So for example, this means take the value of the current value of val and then divide it by what? 2. This function here is the same as value is equal the current value then divided by 2. Okay, so this means the same thing, and you can say that by, we know the current value is 6. So if we run this, we are going to get, you see, you're becoming a programmer. Now, these are things now you need to start knowing. And the only way you can know is go back, try other examples, and that's how you're going to come better. The next type of operators is called logical operators. If I told you we have 3 numbers, so I will put this here as a multi-line comment. We have 3 numbers here. So the first one is going to be 6. The second one is going to be 30. And the third one is going to be 10. There are 3 logical operators. So the first one is going to be OR. So we want to output one of these 2 statements. We have a variable called x. Let's say x is equal to 10. And now we want to test if x is greater than 6. So when we run this, we are going to get it is true, x is greater than 6, right? That is correct. Now, if we want to test if x is less than 6, it is false. X is not less than 6. So let's choose a different number so that it can be easy for us to see. It is less than 1. So it is false. It is not less than 1. So the OR operator is going to test if any of these 2 is true, then it's going to output true. But if both are false or both are true, it will output false if both are false or true if both are true. Now, you only need to say that only one works. When one holds as true, then it's going to output true. We can write x is greater than 6 or x is less than 1. From our earlier tests, we know this is true, but this is false. So when we run this, it is going to tell us true. Why is it true? Because this part is true. If we change this and said x is less than 6 or x is less than 1, both are going to be false, right? I hope you can see that. Now, when you run, it's going to be false because 10 is not less than 6 or 10 is not less than 1. Also, if one of them is going to be true, then it is going to tell you true because at least one of those is true. So you only need to remember that logical operator returns false if and only if both the statements are false. Otherwise, it's always going to return true. The other operator is called the AND operator. So AND simply means both statements have to be either correct or either false for it to be assigned the value true. For example, if we take this one and we input this one here, I now change this to AND, when we run, it tells us true because x is greater than 6 and x is greater than 1. That is true, AND. But if we had x is less than 6 and x is less than 1, when we run, it's actually going to tell us false because both are false. Again, if, for example, 1 was true and 1 was false, now x, which is 10, is greater than 6, which is true, and x is less than 1, which is false. If we run this, it's always going to tell us false. So you can see now where that difference comes in between OR and AND. If you cannot get that difference, you can stop here, move a few steps back, and try to understand. The other operator is called the NOT operator. So the NOT operator, it's simply written as a statement, and it is usually going to reverse the results. So it returns false if the result is true. For example, here's an example. So this is how it is written. So when you begin with not and you input that, so it tells you whatever is in here is, for example here, if x is greater than 6, x is 10 is greater than 6, right? And x is also greater than 1. So when you test this, then it actually means the two are going to give you true. But when you use the not, it is going to reverse. So it is going to give you false. The actual answer is true, but because you have used not, it's going to reverse. So comparison operators are used to make comparisons. We have already used one of them. Actually, we have used a couple of them. Less than, greater than, equal to. Now, I told you when you use the normal equal sign that we have in real life, that is not called an equal sign. It is called an assignment operator. So we have like 6 comparison operators. Let's begin with the first one. It's called an equal. And it is written as this. So it is 2 equal signs. So when we say x is defined as 10 and y is defined as 15. So when we test if they are the same, you're going to be told false. But strangely, if now you're going to use the assignment operator, then it means x takes the value of y. So x is equal to 15 and y is equal to 15. So if you're going to test this, then you're going to have true. So I hope you can see the difference between the equal and the assignment operator. But then there's also another alternative called not equal. So not equal, not is simply the exclamation mark. So it's going to be x is not equal to y. So I'm going to remove this space. Then when we run that, it's false. Because we already said here, x is 15, y is 15. But now if we take these two values, and now we want to define it properly, x is equal to 10 and y is equal to 15. And now we test this, then we are going to find that it's actually true, that x is not equal to y. Because x is 10 and y is 15. So I think that is so obvious and I don't need to give you further comments. Another one is going to be something like greater than. We have already seen greater than before. So when we say x is greater than y, that is going to be false. Why? Because x is 10 and y is 15. But when we write y is greater than x, it tells you it's true because it is testing and it's actually finding that 15 is greater than 10. The other one is less than. So we are also going to have less than. And that is going to use this symbol here. So x is less than y. That is true because x is 10 and y is equal to 15. But when we say y is less than x, it's false, right? If somebody asks you, I want to see all the students who are aged at least 18 years old. So it means if you are 18, so our minimum age is 18. So we want to test if the new age, for example, you are aged 19, is your age greater than or equal to the defined age minimum? So our defined age minimum is x, and we are told 19 is actually greater than. But if we take, for example, 17, it is not because it is false. Another alternative is you can test if you are less than or equal to. So the same way we have greater than or equal to, we can also have less than or equal to. And now that is simply going to have to change this sign here, and now it's going to look to the left. And now when we take our age, our minimum age to be 18, and now we want to test if, for example, 17 is less than or equal to 18, now you're going to get that as true because it is true that 17 is less than or equal to 18. That is all you need to know about comparison operators. Membership operators tests if something is contained within something like a list. So for example, let's say we want to check if a certain letter belongs to a list. We can define a list of letters. Let's say we have a list containing A, B, C, E and Z. So when we run these, and I'm going to assign that. So these are letters. And we can actually see that as letters. Now we want to ask a question. Of course, you can see here it is A, B, C, E, and Z. But let's say now you have a dataset containing 1 million variables, and you want to check if one is contained. So it's going to be difficult. You can use now the membership operator, and this is going to be something like this. Do we have Z in the list of letters? So it's going to tell you true. Now, if you want to check if it is missing, then we, instead of saying in, then we are going to have to use another one called not in. If you say not in, it's actually checking if Z is missing from the list of letters. Because it is not missing, so it means it is false. I hope you don't get confused. Now let's do some actual coding. We are going to begin with what we call conditional statements. Conditional statements are simply going to test if a certain condition is met, and then if that condition is met, we are going to tell it what it's going to do. The first statement is going to be called an if statement. So we can define this problem as follows. We can assign a variable called passmark. So this passmark is going to be anybody who has gotten anything above this is going to be considered they have passed, but anyone who has below this, they would be considered they have failed. So if, for example, you score 51, so your mark is 51, and now we want to check if your mark is actually above the pass mark. So what we will do is we will use the if statement. So your mark is 51, so we want to check is your mark above the pass mark. So when we run this part of the code, it will tell you you have passed. But then we said the pass mark is 50. So somebody who has scored 50 would also have passed. So here we need to say greater than or equal to. Then when we run this, it's going to tell you that you have passed. Somebody who has a 50 would have also passed. And somebody who has a 49, that's not there. So we have not told the program yet what to do when somebody has not passed. So we'll have to come back and introduce another conditional statement called an else statement. So an else statement is going to test if your previous condition has been met, and if it has not been met, then you are going to give it another instruction on what it is going to do. So for instance, we can take this part here and assign it down here. So we say if your mark is greater than or equal to the pass mark, we say print you have passed. But then if your mark is below, then we have to assign another function called an else. And now when we get to run this, it is going to tell you because you have a 49, you have failed. Remember, we defined our pass mark as 50. What happens if the performance is in tiers in a case where you have, say, somebody who is getting 90 and above gets an A, as in this case. So here, if you get a 90 and above, you have an A. And then if you get between 70 and 79, you get a C. If you get anything below 60, you get an F. Using this case here will not be actually an ideal approach. And now you will have to use something else, which we call an else if statement, or simply written as elif. And this is going to be written as follows. You are going to define your mark, and these marks can be used now to test the logic that has been embedded in the code. If we do this, and we say you got a mark of 90, now the syntax or how this code is written is, you will have the first statement, an if statement. So if your mark is greater than or equal to 90, as we already said here, you have to get 90 plus, then your score is an A. If your mark is greater than or equal to 80, as in this case, you are going to get a B. All through up to this point. At the end, you're going to have to put an F, where if you score anything else, we can run this code and test if it actually works. So to run this, you're going to say you got a 90, so your score is an A. Somebody who got an 80, their score is going to be a B. And somebody who got 20, their score is going to be an F. You see? So that is how you are going to use an else-if statement. And you can imagine, or you can think about how this is going to be used in real world. If you are a manager, you're going to be paid 20,000 per diem per week. If you're a senior manager, you're going to be paid 70,000 per diem per week. If you are an associate, you're going to be paid 6,000 per diem per week. So that is where now we use a conditional if statement. Now, there's another special class called the nested if statement. So nested if simply contains an if statement inside another if statement. Now, here is an example that we can use a nested if. I want to run a condition of statements, and every time that statement is true, it is going to check the next condition until I reach to the last condition. If all the conditions are true, then it's going to output a certain outcome. Now here, I'm going to check if you are a student or not. If you are a student, then I will check your score. If your score is above 50 in this test, I'm going to check if you are subscribed to the management diary. If you are subscribed to the management diary, then I'll say thank you. To test these conditions, we are going to use what we call a nested if. So nested if, it means there's an if statement inside another if statement. Here is how it works. We're going to define the three variables. So the first variable is status. The next one is if you're subscribed or not. And then if your score is equal to 70 or not. Now, we will test the first thing. Are you a student? If it is true, then we will proceed to the next step. If your score is above 50, then we will proceed to the next step. So if your status is false, then it is going to output this: you are not a student. But then if you are a student, but then your score is below 50, it is going to output the next statement: your score is under 50. If you are a student, but you have not subscribed, okay, if you are a student and you have a score above 50, but you have not subscribed, then I'm going to say you are not subscribed. Please subscribe. But if you have done all these, I'm going to say thank you for subscribing, right? So let me just add that. Now let's try and run this. So for instance, if we change this part, let's say to true, and now we run this, it means you are a student, you are subscribed, and you got above 70. So we say thank you for subscribing, right? But then if, for instance, you didn't get the pass mark, you got a 40, then it means your score is under 50. But if you are not a student, now this is a string. It means if I change this to student, then it means it will not meet the first condition. Now, if I can run, it can tell you you are not a student because student and student are not the same thing. But if I say here you're a student and you actually got 70, but you are not subscribed, then it means you are not subscribed. Please subscribe. You can see. So that is simply all you need to know about if and else if statements. So based on what we know about Python so far, you may have started asking some interesting questions. For example, in the last section, I showed you how to calculate the grade of a student, how to show the grade of a student based on some rules that have been given. But now, you may have started asking, what if I have 1,000 students? Am I going to do this the same way? Now, there's a solution to that, and it's called loops and iterations. So in this section, we are going to discuss loops. And we are specifically going to discuss two types of loops. The first type is called a while loop. So there is a while loop, and there's also another loop called a for loop. So these two types of loops are going to be very important when you are executing repetitive code. The first one is going to be the while loop. If you remember, there's a place where we actually discussed logical operations where we are going to test if something is true or false. Now, while loop usually leverages on this, and this is how it's going to work. Let's say, for example, you are in a room, and this room has a capacity. So this room has a capacity of 200 people. Now, you want to let in people at the gate, and while you're letting people in at the gate, this is an automated process. So it means it will continue counting the number of people who pass through the gate until the number 200 is reached. Then after which point the gate will be automatically closed. What you're going to do here, you're going to use what we call a while loop. So this while loop is going to execute a certain line of code until a certain condition is considered false. We can begin our example by letting people through the gate until the room capacity is full. So we have said the room has 200 seats. So let's just say, let's call it seats. And so we want to ensure that while the seats are less than or equal to 200, we will print, then let somebody in. But immediately we reach the target, we are going to stop. So how do we do this? If you can remember, I must have showed you something like this. X is assigned the value X plus 1. Or it was also written something like X is assigned the value X plus 1. So this is actually what we are going to leverage at this point. So this statement simply means take the first value of X and then increment it by 1 up until now you reach this point. Now, what do we need to do here? We will take the current number of seats and we will keep counting one after the other until we reach the maximum. So that code is going to be something like this. Or alternatively, you can also write, I said when we use the hash, that is a comment. So you can always write something like this. And this is also going to be a correct statement. Now, we can try running this code and see how it comes out. So here we are told, let somebody in. At the moment, we are at seat number 200, right? And we are told, as long as it is less than or equal to 200, keep executing seat. So for example, if we are at seat number 195, so we are going to have let somebody in 6 times. That if currently the room is empty and we want it to let in people one by one, then it's going to have to be, let's say the room is empty, then it's going to have to execute this line number 201 times, right? Because it's also counting the number 0. Okay, now that is the basic way you can use a while loop. Now the problem is, for example, if we took this code here, and now we want to continue running this code as long as it is 200, you see, Python will continue counting up to infinity. At this stage, if we run this, it is just 0, so it's not going to execute anything. But now, if we increase this number to 200, I'm not going to try and run that because it is going to run to infinity. In short, it's going to count 201, 202, up until it gets to 2 billion, up until it gets to trillions. You can think of whatever number. So it means it will keep executing every now and then, like for a very long time. And sometimes this can crash your PC. If you really want to try, just try, go ahead, and then you will let me know how things went. But then you should know that this execution is actually an infinite loop. So it never stops executing. On the same note, for example, let's say you want to stop when you reach to seat number 199. Here, when we run this code, at 198, it's going to run from 198, then let the next person in, then we are going to have 199, then let the next person in, we're going to have number 200. So that's why we have 3 numbers here. But then, let's say you want to leave at least one space. So if it gets to number 199, stop executing. So in that case, you're going to have to use this code. It is called a break function. So the break function simply gets to a point where it has been designated. If seats get up to number 199, then you're going to stop executing the while loop. So if we run this, if you can notice, these are just 3, but now if you run this, we're going to have 2. So it simply means it gave out the ticket at number 198 and at number 199. So that is the simplest way how you're going to execute the while loop. And I'm sure you have already started thinking about how this is going to be useful for you in your daily tasks. Now, a second alternative is actually one of the key and most important parts or functions, the for loop. And I would like us to think about the grades example that we had earlier, where we had a code that can execute, let's say you got a certain mark, and now it's going to help you classify your score as either an A, B, C, D, or F. And now here I have a list of students. I think I gave them 2 low marks. Let me just try to reward them. So 96, yeah, that looks good. This person here, let's just give them 37. Now you have these students, and this is actually a list, and you could actually get that data type here and confirm that it's actually a list. Now when you're accessing lists, as we said, you can use indices. So the index is going to begin from 0, 1, 2, 3, 4, 5, all through to the last one. I've kept saying over and over that Python usually executes numbers beginning from 0. For example, if you want to access the first number here, you can see it is down here with index number 0. So that is 90. So if you also want to get how many students you have, you're going to have to use this function here called length. So if the data type is a list, you can use the len function, and you don't need to memorize this. These are things that will come naturally, so you don't need to worry. That you can use the len function to see how many students we have. So in this case, it is 10. So what we want Python to do is to traverse through this list, one student after the other. So when it traverses through the list, after you've gotten the student grade for each individual here, you're going to have to check whether this student gets grade A, B, C, D, or F, right? So you won't need to write an if-else statement every other time. So what do we do? So we are going to pass this variable called student grades, and then we are going to iterate. Here we have used an I. You could also use something like maybe a J. Like it is a random variable, a name, anything. You can even call grade, right? But now whatever value you use here is what you're going to use here also. So in this case, just to keep it simple, I'll use an I. So for I in students, so I can be 1, 2. So for I, it will begin from the first one, 0. So for I, which is 0 here at 90, check what is the grade. When I is maybe 1, check here is 15. Then whatever grade you get, output. So it is going to check each, assign a grade, and output the grade because you have told it to print. Now, when we run this, each student is going to be awarded a grade. So you can see here A, F, D, F, F, and these grades are actually what we have here. We can use that, for example, we just use the first and the last one. The first one is 90, the last one is 80. This is an A, this is a B. So if we come here, we'll check this is an A, this is a B, right? But then sometimes you only want to stop when you get to a certain point. So we have all these students, but I want to stop at a point where I reach a student with a certain amount of marks. Let's say up to this student who has a mark of 25. So I will output the value of I until I get to this point. So what I've tried to do here is actually not assign the grades, but now that you know how to assign the grades, you can actually do that as a self-pacing exercise. So I'll try to output the marks up until I get to this mark here. Then once I execute this, because I've assigned this to 25, I will stop. So I can try running that. You can see now the first person got 90, 15, 64, 25. If I wanted to stop at 37, I will simply come here and change to 37. And you can see here, this is an equal sign. This is an assignment operator. So we have said this is a variable, right? But then we say when I is equal to 37. So it will check, do we have values equal to 37 here? Then when it gets to that, it is going to stop executing. But then what if we have a 37 here? So if we have a 37 there, you see it is going to stop at the first 37. So you also need to be aware of such kind of things, and you need to know how Python is actually dealing with your data. That is all about while loops and for loops. And now we can proceed to the next and most interesting part of this Python course called data structures. Data structures happen to be the most important section when you are going to deal with data in Python. But also, it happens to be the most comprehensive and sometimes the most complex part. So what we are just about to look at are data structures, and I'm just going to give you a tip of the iceberg so that you can just be working on what is necessary. But in future, we will get actually to discuss data structures in more detail. Now, we have already seen a couple of these data structures, and simply a data structure tells you how data is stored in Python, or not necessarily in Python, but in any other programming language, because all programming languages are going to have these data structures. So manipulating of these data structures is usually done using algorithms. And I'm going to give you a couple of ways you're going to deal with these data structures. But in this case, you're going to work with strings, lists, tuples, dictionary, and set. You have already seen a couple of these. So we have ordered and unordered data structures. So the first three, this is a string. It is usually written with double quotes. This is a list. It is written inside these box brackets. This one here is a tuple. It is written inside these brackets. And this is a dictionary. It is inside the braces, right? And finally, we have a set. It is also inside these braces. But I had already discussed the difference. You can go back there and check. Now here, we want to focus on something called ordered and unordered data structures. Ordered data structures, as they appear, simply mean that they are indexed. So it means this element here is going to be assigned index number 0. And as I mentioned, indexes usually start counting from 0 upwards in Python. So if, for example, you want to access the first letter, this is going to be letter number 0. And I'm going now to show you how to deal with it. So these first three, as I said, are ordered. And then these are unordered. So unordered data structures, that is dictionaries and sets, cannot accept duplicates. So if, for example, we had 1, 2, 3, 4, 5, 5, one of the first fives is going to be removed. So we are going to have 1, 2, 3, 4, 5. But they are not indexed. So it means you cannot say this is index number 0 and this is index number 4. So we will begin by checking the length of an ordered data structure, and we are going to use lists. But technically, for all the three, strings, lists, and tuples, these functions are going to apply exactly the same way. So we will begin by checking length, and this is checked using the function len. So when we apply this, we are going to get the length is 6. And actually, we can just check that the elements are 1, 2, 3, 4, 5, 6, right? So the next part is going to be checking the smallest number, simply the minimum function. So here we can check what is the minimum number. We use the function min to print the smallest number. And in this case, when we run this, we get the smallest number is 1. Another way of manipulating this kind of data sets is you can actually output the maximum. So, and this is simply going to be max. So when we write max and check that out, so we are going to have the maximum number here is 20. And of course, you can get that. So either in strings, lists, or tuples, you can use the max function to ascertain what is the largest number. Now, can you add the elements in this data structure? The answer is yes, and that is going to be done using the mylist function sum. So when we add the elements here, so you will get that 8 plus 2 plus 5 plus 1 plus 20 plus 15 is going to give you 51. But Unfortunately, you cannot add something like the string because these are not numerical values. So it is going to require you to have an integer, and a string cannot be accepted. So you need to be aware that when you're working with strings, you cannot use the sum function. Next, we have the sort, or rather sorted. Sorted simply means that you can arrange these elements from the smallest to the largest, and you're going to use this function called sorted. So if you're going to check that, you're going to get 1, 2 through 20. And in strings, for example, when we run that, it begins with the special characters. Once it's done, then it arranges all uppercase letters from the first to the last. Then it comes to all lowercase letters from the first to the last. So that's how sorted or sorting strings usually work. And then we also have another function called count. So count is going to be written as follows. So the first thing you're going to have to input the my list, then you're going now to use count. And when you are going to check that, if, for example, we run this, a number like 2, so it's going to give us an answer 1. What does it mean? It is going to count how many times 1 appears inside my list. So far, we have learned very simple manipulation. And at one point, you're going to have to use these. At one point, you're going to have used these types of manipulation. Now, the question is, how then do you access each individual element? That is called indexing. And as I said, indexes or indices in Python usually begin from 0. So if I was to write my list and then say I want to access index number 0, that is going to be 8. If I want to access index number 4, then that is going to be 20. So if you know how to deal with indices, then it means you can easily work with something called slicing. Slicing simply means you're going to take a small part of either a list, a tuple, or a string, and now you can say, for instance, if you want to access from the first element to the third element, you're going to use 3. So when you run this, it's going to give you 8, 2, 5. If you want to access from the second element to the third element, then you're going to have to run this, and now it's going to show you the second element is this and the third element is 5. So this also simply means you can actually access this list from the other side. For instance, if I want to access the last element, I will simply use -1. That is for the last element, then that is going to be this. If I wanted element number 3 from the back, then that is going to be -3. And now if I run that, it's going to be 1. So if somebody asks you, can you sum the first and the last element? So that is simply going to be, the first element is going to be 0, and then the last element is going to be -1. So it means now the sum is 23, and if you take 8 plus 15, you're going to get 23. So that is how indexing actually works. You may also want to do something called concatenating. And concatenation simply, or rather you can just add, although it's not the normal addition in the sense of summation, concatenating simply uses a plus sign. So you may want to retrain yourself how you see this. There's a difference between this and this. Because you already know this is a list, when you use a plus sign for the entire list, it will pick the list, then repeat the same list. If I wanted to repeat it for the third time, I will just add my list. So it is going to keep extending. So it takes the first up to the last element, then it repeats the same thing from the first to the last. So that actually means we can also multiply. Multiplication simply works the same way as concatenation. So that means you can multiply by 2. It means it is going to be repeated twice. You can multiply this by 4. It is going to be repeated 4 times. And you can multiply this by 3. It's going to be repeated 3 times. Multiplication simply repeats the list as much as you have specified. Now, we have already seen something called in function. And we did this a while back, But now we also want to come back here and revisit. If you want to check if an element belongs to a list, now here is our list. Our list has 8, 2, 5, 1, 20, and 15. I want to check if 6 is in this list. So I will just come here and write 6 in my list, and it's going to give you false. You can also iterate. So iterating simply means accessing each of these elements. So if I want to iterate, I'm going to use a for loop. You simply write for I in my list, print I. So this one here is going to print each of the elements. And for example, if we are going to talk about the string, it's also going to be for I in my string, then it is going to print everything that appeared in my string. And for I in my tuple, it's also going to print everything that appeared in the tuple. So we will stop here with ordered data structures, but there is more. And I will come with a separate series actually discussing data structures alone. Now, next, I would like us to talk about unordered data structures. So, unlike the ordered data structures, these do not have a specific order. And we said you cannot index them. And here we have two data types. We have dictionaries and sets. The good thing about dictionaries and sets, they do not repeat. And I'm going to show you that by example. We already defined our dictionary back there as my dict, and also defined our set as my set. So here we have 1 through 5. Here we have name, age, and city. How then do we handle data in these unordered data structures? So we will begin with sets. And we had already defined a set up there called my set, and this is how it looks. We want first to find the length of this set. And I said, when you just want to find the length of any set, you're going to use the function len. So if we run this, it's going to tell us the length of this set is 5. 1, 2, 3, 4, 5. So it means this set is comprised of 5 elements. If we want to add an item to this set, say for example, we want to add a number 16, so we will just use the function add. And now when we run this, we are going to have my set as 1, 2, 3, 4, 5, 16. So when you want to add an item, you simply use the mySet.add. But remember, this mySet is actually the name of the set, and you can call it anything. So it is a variable name and you can call it anything. You can even call it your name. The next thing, you may want to remove an item. And when you want to remove an item, you are simply going to use, as you have already guessed, the remove function. Now we added 16 and we want to remove it. So this is going to be set.remove 16. So when you run this, you're going to have my set as 1, 2, 3, 4, 5 as it originally was. Can we check if an element is in a set? So this one here is what we usually call the membership operators, and we talked about this when we were talking about operators, and we usually use in or not in. We had already discussed this in the most recent section, but if you want to check if there is 2 in this set, you're going to use the in function. So you are simply going to write 2 in the set name, and when you run, if it is there, it is going to give you true. But if it is not there, a number like 12, false. So it means in this set, we do not have 12, but we actually have 2. If we have in, we can also have not in. And in this case, now it is going to check if this element is missing from this set. So when we try to see if it is missing, it is true it is missing. But if we change this to 2 and check if it is missing, it is going to tell us false because that element is actually not missing. The final action that we want to take is to delete all elements in a set. And here we are going to use the clear command. So, for example, this is the name of our set, and we'll simply write .clear. And now when we run this, our set is going to be what we call an empty set. And you can run that, you'll just see it is empty. How do you know it is empty? When we try to check something like the length of this set, now we can have that as 0 because it is empty. It does not contain anything. The next part is dictionaries, and it can actually be manipulated the same way we have actually manipulated the sets. So if we want to check the length of our dictionary, we're simply going to use the len function, and now when we run this, it's going to tell us the length of our dictionary is 3. What does that mean? We have this is the first element, this is the second element, and this is the third and final element. You can add or remove an element. So for example, if we want to add an element, then we are going to use the name, and now we will specify what we want to add. For example, I'm going to add something called element. So that is going to be the name of whatever we are assigning and its value. So let's say this element has a value of 23. So when we run this, we have added this element in our dictionary, and we can check that by simply now looking into our dictionary, and this dictionary has now an extra element called element, and the value is 23. So this simply means you can also delete or remove an item. So to remove an item, you're going to follow more or less the same process. You're going to use the function called del, which stands for delete. And now we can pick whatever we had up here, but without this assignment. And then when we come here and input that value, now we can have myDict, which is actually the name of our dictionary, and run that. It's going to have the element, this one here, missing because we have already deleted it. You can also come here and delete, for example, the first element, which is called name. So when we delete that and run, it is going to be just age and city. But you should see this as age and the information about age. So it's going to tell you there's a variable called age, and we'll come to see this when we come into data frames. So it's going to tell you there is something called age and its value is 25, and there's something called city and its value is London, right? So can we check if an element is in this dictionary? We are going to use the normal membership functions, which are going to be either in or not in. For example, is age in our dictionary? So we will simply come here and write age in, what was the name? My dictionary. So when we check, it is going to return true because age is actually there. But for example, if we say mileage and try to check this, it is not there. Why? Because mileage is not in here. On the same note, then it means we can also use the not function. So this one checks if this value is missing, and it's the opposite of what we've just done. So is mileage missing from this list? If it is missing, it is going to return true. But if it is not missing, for this case, for example, something like age is not missing up here. So if we check, it is false. Can you delete all the items in the dictionary? The answer is yes. And here you're going to have to use the clear, just the same way we did in the sets. We can simply use the delete function, and that is going to be, for example, our dictionary is called myDict. So we are going to take this and then we will input it here. But now we want to delete all the elements. So that is going to be just clear. And then when we do that, now if we run, it is empty. This one here shows you that it's empty. And to know it is empty, you can simply check the length, because the length is going to show you how much information is stored in that dictionary, and you will find there is nothing. What happens then when you want to delete the entire dictionary? So in this case, you're going to have to use the del function, and that is going to be delete and my dictionary. Now if we run, my dictionary does not exist anymore, and we can test that by simply trying to check this, and there is nothing. That is all we have about data structures. But now we will create an extended course, because this is part of the most important parts of Python programming, or any other programming language for that matter. So we will create a more advanced data structures and algorithm course that will be available very soon. What you know so far is just what is necessary for you to actually be able to perform simple manipulations. You may have noticed that things can get a little boring if we are going to have to write this code every other time. And now, we are trying to learn to code because we want to be very conversant with AI and machine learning. But now the question is, what is the essence of writing the same code over and over if it doesn't make things easier? So it's because you have not learned enough yet. Now, here I want to introduce something called custom functions and modules. You have seen a couple of modules so far. You have seen a couple of functions so far. But you want now to create your own function. Think of, we have talked about, if you want to output a range, you simply say range, then you are going to input numbers like 1, 2, 3, 4, maybe something like that. Now, we want to define our own function that can pass some instruction. So for example, if we write range, this is going to store information number 1, 2, 3, and 4. Now, we want to define our own function that does something that we want. Here is the sample of a code that we have been using so far. We assigned the variable length a value of 10. Then we also assigned the variable width a value of 25. So when we want to calculate the area, we assign this variable the function length multiplied by width. And now every other day we want area, we are going to have to run that. So if you get like this being 20 is 500. If this is 251, but now this is getting boring because every other time you want to calculate a new area, you have to come up here and change. Now we can use something called functions. So functions, these are a block of codes that is run to perform a task. And once a function is defined, as you can see here, it needs to be called to perform a designated task. So what you did here, this one here, is what it's said, or it's termed as calling the function range. So this is the way in which a simple custom function is defined. Here, this is a pre-built keyword which defines a function. This here, calculator, this is the name of our function, and you can give it any name. For example, you can call it calculator 1. You can call it calculator 1, 2. So you give it any name, but you can notice that I follow some ways of naming this function. For example, if I wrote calculator 1, 2, and here, instead of using lowercase, I used uppercase, this and the first one mean two different things. You can also see that I've used here underscores and such, but if you want to know more about how you can name, just go look for ways through which you can name functions, and you can always find this information online. This function here does the following things. The first thing is we have defined our function is called calculator. And we have told the function its job is to return this string. This code calculates area of a rectangle. Now, when you want to run this function, you simply input print calculator, or you can also just call the function as calculator. Now, when we run this, it is always going to give us this code, right? We could also have done print and then it is going to give us the same exact code. But now the question is, how then do we use this notion to calculate the area of a rectangle? You have probably started thinking about what you can do with that. But before we get there, we need first to talk about what we call defining variables. So this variable here can be used anywhere. For example, I wrote it in this cell. Now I can still call that, and still I'm going to be told the length is still 20. But within functions, there are rules. There are like 4 types of ways you can define a variable. But because you are a beginner, I'll just tell you the 2 most important. So that is going to be the local and the global variables. So a local variable is only usable within the function. So it can only be used within the function. And when we say within the function, it means anything that appears between the function definition up to the last line. So when we enter the value return, this is where our function stops running. So for example, here, width is a local function. It can only be run within this code, right? But length is a global function. Because we had already named them up here, I want us to use a different name. Let's say length 1, and then we are also going to use width 1, so that we can have this as 2 different variable names. Now, when we run this, we have asked the code. See, this one here is our function. We have asked it that take the value width 1, then return width. Okay, now this one here, we have actually not defined it as we should because I changed that now. So we are asking it, go and look for this value and return it as the output of this specific function. So when I come down here and call the function calculator, so let me just do that. So when I call the function calculator, it is going to run everything that is within this code, right? So if I do that, now it is going to tell me width 1 is 15. That is correct. But we also have length 1. Now, for me to demonstrate that this is a local variable, so if, for example, I took this variable here and now I tried testing it, we are told the variable is not named. But if we run here, the variable is there. So where does the difference come in? The difference comes in because this is a local variable and it can only operate within a function. If, for example, now you will be using functions which will only be having variables that are within that bound, then you will only need to define them as local. But up here, we have a global variable. So if I came here and maybe tried to test length 1 down here, then you can see now it is returning this value of length 1 because this is defined outside the function. Now here is the question, and you're probably asking this question. What happens then if I have defined this function and I've written my code, then I've realized I should have come and defined this as a global function rather than a local function. You can come back and just use the keyword global, and now you're going to input width 1. Now, if we run this code, it's still going to tell us, because the function of this code is actually to return the value width 1. So if we run that code, now this is defined as a global function. Remember, in the first case, when we tried to run this, it told us it is not defined. Why? Because it is within this function. But now if we try running this, you see? Now, at least you're following, and I think you can now start smiling because things are making sense. Now, the question is, then what do we need to do? How can we use this information to solve our problem? Now let's go back to our area of a rectangle problem. So we know the area of a rectangle is defined by length multiplied by width, right? So we can come here and write a function that actually does exactly that. So we are going to call our function calculator. And you need to be familiar with working with functions, because the more you advance with Python and you start working with complex problems, you will now need to work with functions a lot. So here is our function. And we are going to define a few things. So this function has 2 things. The first thing is the function name. Then now we have another thing here. This thing in the bracket, remember, in the first case, it was just empty. But now we are putting in length and width. So what we have in here are called parameters. And now we are telling this function that the calculator function takes two parameters, and that is length and width. So every time we will need to calculate the area of a rectangle, we will be calling this function and just pass. So this is called passing, pass the arguments. Now they are called now arguments. When now you come down here, when you want to run that, these figures are called arguments, and they are exactly going to match these parameters. So somebody could say, pass that argument to this parameter. So the argument that we are passing is 10 to the parameter length. Now, you remember the F strings. I've just put this here so that you can see how this code goes. So we have defined our function. It's called calculator. We have defined our parameters. And now we have told the function to print this string. The rectangle has a length, this, because now this is going to be passed as an argument. It's going to pick what that argument is and enter here the value. And also the width is this. So when we run this, we are going to get, the rectangle has a length of 10 and a width of 15. But has this actually solved our problem? Not yet. But now at least I hope you're following. So if, for example, we want to change this length to something like 25, now you see it has the length 25 and width 15. So if we want to change this width, we just change that. So simply look at it like length is what appears here first. Width is what appears here second. Now, how do we then calculate the area of a rectangle? Given what we already know. So we already know up to this point, right? We already know up to this point. But now we have something new here. Area is equal to length multiplied by width. And if you remember very well from this part, I told you, you can define a local variable. Now, this is a local variable. So we have defined a local variable called area, and it is assigned the product of length and width. So this one here is going to perform the normal mathematical manipulation, which is multiplication, and then it is going to return the string the area is, and then we are going to get this value. So you can see now when we run that, the first string here tells us the rectangle has the length 10 and width 15. The area is 150. And how did you get the area? You just got the area by running this code. But now if, for example, you try to get the area down here, you see area is 520. Where does this 520 come from? We already defined that this is actually this code. So it means it is still collecting information from up here. It has not yet changed or updated. Why? Because this is a local variable. So if we call this, for example, area 1, so that you can see what I'm trying to say. So if we call this area 1, now if we change this to area 1, we don't get anything because this area 1 is a local variable. So you need to define it globally. Now, to calculate, you only need to do something calling the function. So down here, you have already seen us get the area by simply running this. But how do you call the function? This is how we call the function. And when we call a function, we pass arguments. So what we mean is we write this function name. So our function name is calculator. And then we pass the arguments length here and width here. So when we are going to run this, it is going to perform everything that is done here. So you don't need to be writing this code every other day. The only thing you need to is to come here and call that function. You call the function by entering the function name and then using these two brackets. And then after that, you're going to pass the arguments. So our arguments are that, and now this is going to perform this as it is. And you can now call this function anywhere within this notebook, right? Now, the question is, can you have different ways of defining your arguments? So we already said these up here are parameters, and these are arguments that we pass. But maybe you want to perform a calculation that has so many rectangles. Let's say, for example, I have this. So we can use the arbitrary arguments, which is usually a definition of we know the length, for example, but we don't know how many widths we have. So let's say you know exactly, you have a lot of rectangles. You know exactly, they all measure the same length, but they have different widths. So you're going to define this argument, and this is how it can be understood. So far, all this part should be familiar with you. But now, at least this looks a little bit different, right? Why does it look a little bit different? Because here we only had 1, and we only had 2. As a beginner, I'll be honest with you. You only need to know up to this point. But now you will get to advance to later stages, and maybe you may want to come to this video maybe after 1 year, and now you will be like, aha, now that makes sense. So this one here, you're going to pass only one argument containing information about the length. Then everything else from this point going forward is going to be captured within this width. So this simply means we know that the value of length is defined. It's just one argument. But for the width, we don't know how many they are. And I will show you that shortly. So if I run this, I've used a for loop so that it can output the results for each. So the area for the first rectangle with the length 10 and width 15. The second rectangle is going to have the length 10 and width 22. The third is going to have 10 and 18. So when I run this, so I'm going to get these results. Length is 10, but the width keeps changing, and the width begins from here onwards up to this point. But you can also have this maybe as just 2. So if I run that, you see they reduce. Now if I remove everything and I only remain with this, now it becomes the normal function that we had. So it means you can call the calculator functions with as many arguments as possible. But then this has focused on the problem of passing arguments. So here it means we have so many arguments, right, that we can pass. But now the question is, what if actually it's not the arguments that change, but rather it is the parameters that change? For example, we are taking information about a certain unit with length, width, height, shape, blah, 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 color, and such stuff. So you're going to define the arbitrary keyword argument. So up here, we are going to have now, instead of having the arguments that we pass that are going to change, now we want the parameters to be the ones that are changing. So it means we simply write the arbitrary keyword arguments, which is shortened as this. You will get to see this quite often. And this actually means this. So this is for the arguments and this is for the parameters. But now we are going to pass something like a placeholder that can accept as many arguments as possible, right? So when we want to run this code, we will define the function, and then we are going to pass our arguments based on the current problem. Unfortunately, this is going to come out as a dictionary, so it means we are going to have to access the elements of the dictionary. And now we are going to define the variable length by accessing this, and then the variable width by accessing this. And this is how we do it: measurements, length, measurements, width. Then after that, now we can proceed to calculate the area. If this confuses you, don't worry. It is just going to take some time before you get familiar with these things. But as for now, at your current stage, make sure you understand up to this point. Because in future, when now we'll start defining functions for machine learning specifically, then it means now we will have now to come and revisit this if necessary and try to make ourselves familiar. Normally, when you're working with big projects, you're going to have to write a lot of functions. Now, what I want us to do here, I want us to define what we call a module. A module is simply going to run a set of functions together, just the same way we have had a function running a set of code. Now we are going to define a couple of functions, 1, 2, or 3 functions. Then after that, we will try and save a module, and then from which we will try and run and see how it works. Let's continue with our early example where we are going to have to continue calculating the area of a rectangle. So we will define a function that actually takes two numbers, length and width. So we will define a rectangle, and this module is going to take length and width, right? So we want this module to return the area. So we will say return length multiplied by width. So this is our first module. And then the second one, we want to define another module that sums the length and width. So let's say it performs the perimeter. So we will define another function called rectangle. And this one here is going to also take length and width. But now instead of returning the product, it's going to return the sum. So it's going to be return. And now we are going to have length plus width. Okay. So I hope we are at home with this. So we have these two. Now let's rename this, let's say to area. So if we run this and we run this. Now if we call this function, it is going to be 10 and 23. And now it's going to give us that the area of the rectangle is 230. But now if we call the second function, it's going to give us something else. So 10 added by 23 is going to be 33. So we want to wrap these two functions into one module. How do you do that? It is simple. Now you will click here and under this, add a Python file. And we will call this file something like save Python file as, and then we will call this our summation. And then we will save. So we have summation.py. So let's copy this function and paste it here. And also come down here and copy the second function and paste it here. So if you've done that, now you can simply save. And when you come to this side, you will actually get a file called summation.py. Now we want to use this to calculate the sum just the same way we have done here. So you will do something we call importing the module. And that is going to be import summation, right? Now that we've imported summation, we want to calculate the area of a rectangle. So the simple thing you will do is you will take this, you are going to write summation.area rectangle. In short, so what you are telling it, within the summation module, I want you to access the area rectangle function. And now you're going to pass the arguments. We know it is 10 and 23. When you run this, you're going to get 230. That if you want, for example, to get the perimeter, you're going to have to use summation dot perimeter, but now you're also going to have to pass the right arguments. And when we run this, you're going to get 32, right? But you don't always want to be importing as summation. You will notice when we get to that part that people have another renaming convention. So if your module is called summation, you can call it SM, you can call it AB, you can call it anything. So for example, let's call it SM here. So instead of writing summation, you could simply come here and now run a code instructing it to import summation. Then after that, access the rectangle function, the area of a rectangle function. And now when you run, you're actually going to get 230. And the same way, you will get this. And now you can simply shorten this because you have already renamed it to something else. And now when you run, you're going to get 32. That is the very simple way through which you can actually write, access modules by using predefined functions. In this part, we are going to discuss how you can manipulate files, and I'm going to show you how to create the files, how to work on them, and also how to deal with exceptions in case errors arise. Now, when we come here to our working directory, you can see so far the only thing we have are these 2 notebooks, right? Now, we can create a txt file using this code. File, so this is a file name that we are going to assign. It is a variable name. We are going to use the function open, then we'll get the file path, what we already have up here. There are alternatives, so I'm going to show you if you did not opt to use this, you actually went to use the exact file path. I'm going to show you how to do that. Now, once we include our file path, because it's a string, and we have already talked about strings, we are going to add and make sure you have these 2 backslash, then the file name that you want to be saved, and now we are going to input here because it is a .txt, so this is our extension for a .txt file. So we will say .txt, and then we are going to specify the mode as W. There are so many modes, and this is what a mode means. A mode is going to instruct what permissions you are giving to be operated on this file. For example, when you specify read, the only thing that a person can do is they can import and read, but they cannot add or remove anything. When you are using the file write, it means you are going to have to add or remove something from a file if it is existing. And if it is not existing, it will create a new file. But remember, read does not create any new file. So if we try to read a file that does not exist, it's going to give us an error. There's also another one called append. Now, when you use write, it takes the file that you have specified and begins writing from the beginning. So it means it is going from the first index. So it is going, if there's anything in there, it is going to delete as it writes again. But append, it is going to begin from where you had left. And I'm going to show you that by example so that you can see. So if we create this file 0, and now we try to run this code, but remember, we have specified our file name using this, and be very careful. So when you run this, running is Control Enter, then now I have created a file called file 0, and I can come back here and check if I have it. So if I refresh, I actually have a .txt file down here called file 0, right? At the moment, this .txt file is empty, and now we are going to work on adding, removing, and editing information in there. Then, now let's come back here and look at other ways to create a file. So now that we have already defined what a mod is, so this file, this should look familiar. However, you can also specify this one here as it is, but now, instead of you using the file path as a variable that we have passed here, you can simply copy this path and then you're going to input it as it appears, right? Here we are using double backslashes, but here we are only using one. And we are going to have to input the file name and then .txt, the mod is as already defined, but the difference now is you will have to input this R here. So if we try to run this, we are going to get the second file called file2, and that is called file1, and that is here because we have started counting from 0. Another alternative, another option, you can also use this here. Open. Now, instead of using this R, you can add an extra backslash to this, another extra backslash to this, and then here when you're going to define a name, you're going to input 2 backslashes like that. Then after that, you're going to add the file name .txt. So this here is not very necessary. You can just write W and Python is going to understand. So if we still run this, we are going to get file, our file number 2 is in here. So that is 3 different ways you can write TXT files. So you can go out and try for CSV, XLSX, and JSON after we are done with this part of the course. Now, the important thing is when we checked, our TXT file was empty. How then do we get to write information into the TXT file? So if we open this, currently it is empty, and I want us to put in information here. So we will use the write function, and we are only going to manipulate this first file here, file 0. So when we write file 0, this is the file name that we had already defined, and then pass this string and then use \n. So this one here tells Python that the cursor should go to the next line. So if we run this, it means we have written this string inside our txt file, right? And here you can see that you have been shown a number 30. What does that mean? The number 30 simply means that this information that you have passed has 30 characters. So if we try to get the length, we're going to get that as 30, right? Of course, you can know that there's a white space here. So if we tried, for example, running that, it's going to be just 29. Okay, we can also write another text. And now we are going to write enter. So we are going to enter. And now it's telling us the second line that we have just added has the length of 34. And of course, you can see that using that. And when we run, we are getting it as 34. If we try reading this file, we are going to get an error, unsupported operation. And now this can be a challenge because we want to know what is in our document, what we have passed to the document so far. You will notice that the problem with this, the main reason we have this error is because here we said that the only mode that we want active currently is the write mode. So it means Python understands this file is only to be written. So we have not specified that we also want to read this file. To do that, we need to pass more than one modes at the same time. And here we are going to have to use these three types of modes. So you can use R+. It means whenever we have a file that is open, it is going to read the file and then start writing the file from the beginning. For instance, if we have a file and we have created or added this kind of a text, then it is going to start from right here. So the cursor is going to start from right here, the beginning. Okay, so if you add anything, it is going to continue writing as you can see here. Then it continues that way until it gets to this point, then it goes down. So that is R+. You can also write and read. This means you're going to have to use W+ as your mode, and before it even starts writing anything, it is first going to come here and delete. And then now it can start writing new things, okay? And the final one is going to be the append and read. So the append and read simply means we are going to use the A+ mode. And here, if the file is not existing, it is going to create a new file first. Then after that, it will start adding information. But if the file already exists, it is going to open that file and then it will begin writing the information. But now, instead of beginning from here, as was in the case for these first two, it begins from where you had left. So if you want to add new information, it will just start from here and then it's going to continue with our new information. I hope that makes sense. Now I want us to try an example using the A+. So I want us now to open the file because we have already created the file here called file0. I want us to open the file. Then after we have opened the file, we are going to continue adding information later. So I want us to open the file, read the file, then continue adding information later. So we can run this code. And now we are going to have information about our file. For example, we can now try to read this file. And then there's something I would like you to see there. If we run this, we are going to get this is the management diary. You are about to become an expert. And this is actually the text that we defined up here. So our file 0 contains that information. Now, we have seen that. Can we now try something else? I would like us, because we know this file 0 already exists, I would like us now to change this to file. Remember, we created a file called file1. So we will try this with file1. And now we are going to try to open file1, right? and then see if it also has the same information. So when we copy this and enter this, so if we check file 1 here, it is telling us that file 1 is what? Empty. So this means file 1 is empty. Now, can we try adding this text to our file 1? So we can have this and then say this is now file 1 and this is file 1. When we run this and then now try to read file 1, again it tells us it is empty. Then where exactly is the problem? Because we already know that we have added this text. This is because we specified as A+. And I said when we are using this append and read, it means the cursor is always going to be at this point and not the beginning. So when the cursor is here, it starts counting anything that appears from here onwards. And it is not going to find anything. So if you have to change that, if you want to know now how much information is there, you will have to bring the cursor to the beginning, right up here. So in that case, it is going to be file 0. So in our case now, we are going to change that to 1. And then this is also going to be file 1. And then now we are going to do what we call file1.seek. Then we are going to pass this 0. It means take the cursor to the very first point. Then after that now, we can read that file once again. So when we try running this, we finally have it. This is the management diary. You are about to become an expert. Okay, now that we already have all this information, we now want to close this file. That is the final step. So if we want to close file 0, I'd like us to use what we call this close function. It is simply going to be file0.close. So if we run this and now try to see if we can still read file 0 or rather if we can take this cursor to the beginning, because if the file is open, the cursor will actually go. If it is not, it will return an error. So if we try that, it is giving us an error because this is a closed file and we just closed it. But we have not closed file 1. So let's try and close file 1. Let's try and see if we can move the cursor to the beginning of file 1. And yeah, so you have taken it back to the first step. Now, can we handle exception? Because as you have already seen, if you try to open here file 0, you are going to get an exception, right? So this error is going to be raised. How can we handle exceptions? Now, to do that, I'd like us to try and work on a new file. So I'd like us to see if you can remember from the part where we worked on exceptions. I have a complete code here, so I'm not going to have to take it in steps. I'll just try to explain to you and you're going to understand. I hope so. So if you remember from the part where we were working with exceptions, the first part is you're going to try if this code brings an exception. If it brings an exception, you tell the code what to do if an exception arises. Then, if no exception arises, then you're going to have to use the else. Actually, I could have also added here an else code. Else, maybe print nothing. So I could say nothing. Then after that, now we could say now we have the try. Then it is going to check to raise an exception every time there will be an exception. And if there's no exception, this part will run. If there are exceptions, this part here upwards will run. And it will execute and return one of these. And then finally, this part must be run regardless of whatever happens up here. So I covered exceptions in detail and I told you, I promised you we will come to talk about them or use them under files. So this is how we are using them. Now this code, as it appears right here, it runs as a standalone and you can pause here and try to type it to your PC and you will see it actually works. Now, I want us first to check the path the same way we did up there. If you know your path, just leave these as comments. If you don't know, you can remove the hash and the hash. So when you run, it means it's going to import OS, the package OS, and we are coming to talk about packages shortly. Then after that, it is going to assign the working directory to file path. Then we will create except file, which at the moment does not exist, because if you come to check here, this code is saying the except file does not exist here, and that is true, right? So the next thing is we will now proceed to create an except file. I would like us to use here .txt. We are going to have mode is going to be R+. So it means from up here, it is going to be read and write. Okay. Then after that, now I'd like us to have this part, except file.write. So once we have created this except file, we are going to write, I am happy today. I hope you are happy. We have now created a file and written this information, I am happy today. Now the question is, we are going to take this cursor to the beginning. And this is useful if here we actually specified A. Otherwise, if we didn't, it is not very useful because R is actually going to have the cursor at 0 anyway. And this is what I explained right here. So it is the exact same thing I did here. And I hope you understood. Then after that, now we are going to check the content of the except file. If there is a content, then we are going to pass that to a variable name called content using the read function. This also should look familiar. So this block, if it does not raise any error, it is going to return the content of that file that we have created and added information. And that is exactly what we have done up to this point so far. But what if there is an exception that is raised here? And there are a lot of exceptions. So I used 3 types of exceptions here, but there can be many more exceptions, right? So we have this file not found error. So you're trying to read a file, for example, using the R, we said R alone reads files that only exists. And I'm actually going to run it as it is later and you will see. So let me first finish. So if there's no file, then it's going to tell you there's no file. So, and this file path is what we defined somewhere up here. So it is telling you wherever you are reading from, the file you are looking for is not available. Permission error means the file that you're trying to access probably maybe needs a password. Probably you are trying to modify it and it is on R. So it means that one is going to be a problem. Then there can be many other exceptions. So I'm going to pass here exception as E so that in case there is this exception that is raised here, it is going to read value error and store it in the variable E. Okay, then it is going to return and tell me the following error was found. So for example, if it was this case, it is going to tell me the following error was found, then in E, it is going to store value error. So it's going to tell me the following error was found, colon. Then, if there is no exception, and it has given us this, then it is going to print nothing. It means we did not find any error. Okay, so technically this part is redundant and you can see that because, yeah. Finally, you're going to use this finally function to tell the code whatever happens up here. It doesn't matter. Whatever happens, do the following. The first thing is, does file 3 exist? So the first thing is going to check if file 3 exists. So for example, if I passed R here, file 3 does not exist. So it means it is going to return this error, right? So if file 3 exists, then, so this is an if statement and it's going to be a boolean if it's true or false, right? So if file 3 exists, that's true, then check if, now that the file exists, is the file open or closed? If the file is open, and now we checked this condition earlier. So if the file exists and the file is open, continue executing this code. Here, we are going to find the file 3 exists. And the file 3, if we run this code now, it is going to be, it is open. So therefore, it is going to return true. So if it is going to return true, then it means it is going to have to execute this part. Close that file. So when you will try to access file 3 after this point, you are not going to find it. And this close command is going to close the file and save it, right? Now, we have specified here our mode as R. I hope you remember what that does. Now let's try running. We find this error. Oh, okay. I know where that problem comes in. So we defined the wrong name. So I'm going to copy this, and then I'm going to have to put this one here because we are actually currently working with an except file. So I continued counting 0, 1, 2, 3. So if we run this, we are going to find the directory path does not exist. Why? Because we have not created that file yet. And R is only supposed to open a file that exists. Now, if we try to come up here and change this, for example, as we said, here it is going to be, we want to append and read. So if we try to add a plus and run, now we have created and we have also tried to read. And now you can see here we have, I am happy today. And the file has been safely closed. I hope now that makes sense, right? Then nothing is going to execute correctly because this part was there. So that is how we deal with exceptions. And now we want to find if our file was saved. Here we saved it as except file. So we can come here and find our .txt file here called except file. So that is how you are going to deal with files. Now, for your test or for your exercise, can you try performing the above actions on a .csv file? And then you'll tell me in the comment section what challenges you encountered. When we executed the most recent code, we found this output. And I'm sure you have seen a lot of these, and sometimes it gets irritating. So, what exactly is this, and how can we deal with it? This is called an exception. And dealing with this is called exception handling. So, an exception is simply anything that interrupts an execution of a program. So, if you are running a program, line by line, this line, next, this, and this, but then there's an error in cell number 2, if we get this error at this point, all the cells beyond this point will not be executed. Now we want, in case there's an error, we can actually proceed executing the code anyway. So that is called exception handling. And you need to understand first what an exception is. There are a lot of exceptions in Python, but I'll just give you this highlight of the most common. So exceptions can come out as a result of a syntax error, there is a runtime error, or logical error. These first two, you will be able to see them while you're executing your program. However, the last one, you will not be able to see it. So you need to be careful with the last error. So the first error, which is called the syntax error, simply occurs when you do not follow the structural rules in Python. For example, we said if you want to print age, you will have to write print, then open a parenthesis, and then write here your string, and then run this. But then when we look at this, you have used actually curly braces. So if you try to run this, you're going to get something called a syntax error. Simply, it means you have not followed the right rules. Some errors are executed, or some errors are only found during the runtime phase. For now, we will try to focus on these just few errors, and then we can see how to deal with it. If you try to add a string and an integer, you will come across what we call a type error, because this here is a string and this here is an integer. So these two cannot be summed together. There's also another error called the value error. For example, if you are trying to pass the string age and change the data type into an integer, you're going to get a value error because it is not possible to change into an integer data type. Another error is called the zero division error. So here, you're trying to divide a number by 0. Mathematically speaking, let's just be honest, this is never going to occur. And if you try to do this, you're going to get an error. It's called a zero division error. Another common error is going to be the index error. So let's define our data that we have a list containing 2 instances. So this string age and the number 25. So if we want, for example, to access the first instance, we're just going to use the index 0 and we will see that this is actually age. If we want to access the second one, we are going to use the index 1 and we will get this one here is 25. But now if we proceed and say use 4, this is out of the defined index. Now you are going to get something called an index error. On the same note, you can actually get another error called an indentation error. This error usually occurs when you have indented your text in the wrong format. For example, if I do this, now when I try to run that, it's going to give me an indentation error. So those are some of the most common errors that you're going to find. But then there's also this logical error, which you're not going to see any output, or it's not going to raise an exception. And you need to be careful with this kind of errors, because look at this. So you have been asked, for example, a person who is aged 18 is going to be allowed into a club. But now, in writing your code, you have only specified that this person should have age greater than 18. So this is going to exclude 18. I hope that makes sense. So if you run this, it's going to tell you this person is denied. But the logic or the rules are this person should be either 18 and above. So that should have been something like that. So this is allowed. So this is the correct logic. But here we did a mistake. So we are going to get the wrong error. Now the question is, how do we solve this? You will use this exception handling where first you will write try. So try here is going to test for your code. And we are going to check if this code is going to return either a correct value or an exception. So if it returns an exception, instead of the code crashing, it will tell us type error, you cannot add an integer directly to a string. This one you can change to anything because it is giving you a message. So for example, if we try to run the first part of the code, right here, we are going to get a type error. But now for the second part, if we try to run, we are going to get a message instead of the error. So it means if there was another code down here, it will continue executing. So what if there's actually no error and this code does exactly the right thing? For instance, if we took the same exact code, and of course here, if we try to run this code, we are going to get the type error. But now you passed the right information and say you entered age as 12. Now, when you try to run this, you're going to get code executed successfully. So you can use the else function to always return a certain message every time the code has been executed successfully. So if there's an error, it is going to tell you, in this case, the error is you cannot add an integer directly to a string, this first one here. But if you change this and now the code executes successfully, you're going to say code executed successfully. Now, what if there is something that you must do regardless of whether there is an exception or not? Here, you're going to use another function called finally. So we will copy this code and then we will print it here, but now we will add something else. And this something else is going to be the finally function. So this implies that first, it is going to try and find if there's an exception. So we'll try to create one here. We will write something like age, and then when we run this, it's going to tell us you cannot add an integer. Then it skips this part and directly comes to the finally section and executes. So this is going to be important. If there is something that must be done always, even if your code has an error in it. So for example, you want, after you're done with everything, you want to save this notebook. So it means we are going to have a finally section here that will do whatever task that must be done regardless of whether there was an error or not. So if we changed this, and instead of having a type error, we changed this to 12, then we run, we say the code executed successfully. So it means there was no exception, so it had to skip this part. And now it was going to proceed to the else section and tell us the code has been successfully executed. And finally, it is going to have to print this section. So you should always remember this is going to be executed regardless of whatever happens up here and above. If you have followed this tutorial this far and you understand most of the things that we have done up to this moment, then I think now you are ready to start analyzing data. And this is actually the final thing that you need to be working on before you can finally try to perform very basic data manipulations. Here, we are going to learn about libraries. And before we begin talking about libraries, I believe you remember previously we talked about a line of code like print hello world. And we said if we wrap codes together so that they can be implemented as a unit, that is called functions. And then we said when we have a lot of functions and put into the same file and saved in the PC, in the sense that we can call them, we said those are modules. Now, when you have a lot of modules, you can also put them together into something called a library. There are a lot of libraries in Python, and libraries can be either user-defined, you can make your own library, but you can also find libraries online. Now, these libraries, some of them usually come within Python. So when you install Python, they are going to come with it. Something like Pandas and Numpy. So the most basic libraries that you need at the moment is just Pandas and Numpy. And how willing you are to practice than actually what somebody else is going to teach you. Now, let's begin from what we know. People who have tried manipulating data before will find this a very slow and painful process. But I'm doing this because I'm trying to also bring along the people who are doing it for the first time. And this is not the best or most optimum way. But once you get conversant and you learn more about Python, now you will know better ways to answer this. So let's begin with what we know. This is client data and it's financial data. And this data contains information about the employment status of an individual, which is full-time, the age of an individual, which is 34, the occupation, which is engineer, the annual income, which is 72 grand, savings, which is 18,500, and credit score, which is 745. Now, I would like us to use this library called Pandas to manipulate this data more easily. So Pandas, the first one here, is used to manipulate data frames. And as much as we assume it comes pre-installed within the library, I need to show you how to install so that in future, when you run across an error that the library is not available, you'll always remember this day. So when you are going to use a library, you need to use something called pip. So if you're working on a Windows PC like this one of mine, so you're going to have to do pip install pandas. But if you're working on Mac and the others, then you are going to have to just deflect a little bit and check how you're going to install that. So libraries, they need to be installed using the pip function, right? So here we are going to work with pandas first. So we are going to install this library called pandas. Okay. It is in your PC, I know it is. But now I'm showing you this so that at least you can know how to do this in future. So if you install, as you can see here, it is telling me already satisfied. It simply means I already have pandas. Now, you must have seen this before. Import pandas. Up to this point, it means we now have pandas in our PC and we want to import it into this notebook before we start working on it. And we actually talked about that when we were discussing modules. So this should not be something new. So we are going to have to import pandas. But we don't always want to be writing pandas every time. So we are going to give it an alias, a short name, like just the same way we can say JFK for JF Kennedy, or KE for Kenya, or GB for Britain. So this is an alias and you can call it anything. You can even call it PDF if you want, but you don't have to do that. because this is a convention, it means most people usually import it as PD. So don't try to be so different. It is going to create a lot of confusion. So just import pandas as PD. So now you have pandas imported in your PC. So before we start, I would like us to look at our data. So this is how our data looked like. So we had two things, columns. So we had columns and data, right? So those are the two variables that we have defined. So looking at columns, this is how it looks. In Pandas, you can actually change data into something called a series. So a series is simply a single dimensional array that is going to store data. Think of it as a column in your Excel sheet. And actually, this is also where we get to talk about those things, how you are going to use data from Excel. So if, for example, we assign now this data that we had that was previously defined, because we know we have a variable called data, we can create something called a series. So a single dimensional array holding data of any type, right? So if we enter this, now we are going to have a series called person1. Now, when you look at this series, this part here is the details that we already have or something that we have already passed. But we also have this other part from 0 through 5. So this one is what we call an index. And when you have an index, these indices needs to be named. So for example, we said employment status is going to be full-time. So we can say this column is going to contain our index. And indices in future, when we are going to try and manipulate data, we are going to try and have unique indices so that we can easily work on the data. So to create an index, we are going to have A as a new variable. You can call it anything, all. Okay, that is. So we can also call this new variable all x, right? So we can actually create an index for this data, as I have just mentioned. So we are going to run this code. And here we have created an array called Alex. So, okay, a series called Alex. And this series contains information about data, which is what we have here. And now index is going to be the columns. So it's going to be like the first, instead of 0 here, it's going to write employment status full-time. So if we run that, we already have it. If we run it here, we are going to find that now the information has been properly arranged so that somebody can easily come and read, Alex, this individual has an age of 34, savings of this. But now the question is, what if we have 1,000 people? We can't be storing data like this. So we need to come up with a different way. This is where we come up with something called data frames. And data frames, now, if you are hearing this word for the first time and you are going to be in data, just know you are going to hear it forever until the day you decide you are no longer going to be in data. But now that you have heard it for the first time here, you are going to hear it forever. What we call data frames is how mostly two-dimensional data is stored. And you can think about a lot of things. A lot of things usually get stored in 2 dimensions. So something like here, in our case, it's financial data. So this 2-dimensional data has rows and columns. And I would like us now to define a new data set where we are going now to start to understand this concept fully. Remember our earlier example, but now in this case, we have employment status full-time, right? For the first person. Age, just like that. So I think from here upwards, it can look familiar. But now we have more people. So we have the second person, third, fourth, fifth. So we want to store this information in a way that we can understand it. And we are going to use something called a data frame. And you're going to have to call pandas always. So if we run this, now we are going to have information about columns, about data, and about names. Now we want to have, for example, this is going to be, so the first person is going to be Amina, just the same way we had Alex up there. The second person is going to be Wei Chen, just the same way we had Alex up there. Then the third one is going to be Sofia Rodriguez. So here we have number 1 is Amina Hassan right here. Number 2, we are going to have another one. I'm sure now you can imagine that. Number 2 down here is going to be Wei Chen. Then number 3 is Sofia Rodriguez, another one. So we have all these, and they can be any size, as big as you can imagine it. Now, if we run this, we want to create a data frame that we can easily understand. That one is going to be written using this simple code. Now, this is the name of our data frame, and you can call it anything. This is a variable name, right? You can even call it example data. But when you are calling PD. And we said up here, we imported our pandas as PD. So in short, when you see PD, it actually means we are calling pandas, right? So here we call pandas. And then we assign this keyword called data frame. We are telling pandas that we want to create a data frame. How do we create this data frame? We are going to take the data, what we have in here, to this. And this is actually a 2-dimensional list. So if you check data, this is what we call our data, right? And now when we check the type of our data, it's going to be 2-dimensional. So what do we mean by 2-dimensional? It means we have the first person, right? The second person, the third person, the fourth person. And again, we have the first column, second column, third column. So in short, I'm going to try and run this. Now we can run this and we can now see this data as you normally get to see it. Now, this is your first journey to analyzing data. You need to congratulate yourself for getting this far. Trust me, if now it makes sense up to this point, now you are ready to become, an analyst for now. Then we can get to talk about things machine learning way later, things deep learning way later. So here you can easily see the data in an easy and understandable way. So this looks like a little bit like chaos, but now we can see our data the same way it appears in Excel. So we can ask, Amina Hassan has an employment status of full-time. Liam Scott has an annual income of 84 grand, right? Moana is here, has a credit score of 735. Now, can we access something like all the savings that we have? Yes, that is possible. Now, when we are dealing with data frames, once we have created this data frame, we simply come here and proceed to be calling this data frame by its name. Of course, we have the name is financial records, and you can have that. Financial records, savings. So it's going to tell us Amina Hassan has these savings. Wei has these savings. Liam has these savings. Okay. Now, I think now you can get to see. It also tells you that the variable we are looking at is called savings. In just a few minutes, I will also get to discuss what variables are and instances and such things. Then it tells us the data type that we have is float. So we had already discussed this. You don't need to get so confused. Now, then what is the importance of pandas and working with data frames? So to be able to understand that, I will bring you now this first thing. We can get the total. How much savings do all these people have in total? So the sum of this. So we know that we can access the savings like this. So to get, for example, the savings, the total savings down here, we can simply write, so we create a variable called total savings. Then after that, we can have financial records and now savings.sum. This means it's going to add. When we run this, it's going to tell us our total savings are 117,800. Okay, that's just the first thing. You can also get information about the data frame. So to get information about the data frame, you simply do financial records.info, where the financial records is the name of the data frame. So when you run that, you get the information about the data frame. It has 5 entries, and it starts from an instance called Amina to an instance called Moana Terangi. Now, here it is looking easy because we have used names, but in future you will be working with data that has, for example, employee codes or special unique characters that you can be able now to refer and say from serial number 600 to serial number 800. Okay, and then it's also telling you that we have a total of 6 columns. So these 6 columns begin from column index 0 to index 5, and this is the information about those columns. This is the number of values that are non-null. So it means this information is not missing. When we'll start talking about data analysis and EDA in full now, this is just a very small part of it, 0.00%. But now when we'll start talking about EDA in full, we'll start talking about things like missing values and such. Now, here, we don't have any missing values in this. And then it also tells you the data types. For example, employment status is an object. Age is an integer. Occupation is an object. Annual income is float. So if you want, for example, to change from one data type to another, you can very easily change that. And I'm sure you should be remembering that from the previous part of the course. Given this, you can now extract information, specific information about, maybe we want to know who are rich people in our data set. And let's define a small data frame here called rich and say you are rich if you have income of above 20 grand. So we already said if you want to access savings, you are just going to write this, the name of the data frame and the variable name, right? So can we get all the people who have savings of above 20 grand? Because we think those are the rich people. Yes. So if you run this code, you can get these are the people. And also you can get people who have less than this. And that is going to be this. Oh, very. That's going to be this. And I don't know if this is poor, but yeah. They're also rich. Let's just call them rich. Now, we want to talk about this individual here called Moana. And I want us to continue using the original data frame. So the original data frame was this. And now I want us to access individual information about one person, Moana alone. So there are 2 ways you can do this, and I want to show you both, then you will decide which is going to be useful for you. One way is you are going to use the index name. So from now onwards, this thing here, the unique part here, is called index. And it means we don't expect to find 2 Moanas here. It's only going to be 1 and 1 Moana. If there are 2 Moanas, then we will get to discuss how that is going to be dealt with. But as for now, just know it is not supposed to have duplicates because it is supposed to be a unique instance. So if we want to calculate financial records for Moana, and we want to use the name or the string containing information about that instance like this, then we are going to use, and look here very clearly, the loc function. So here it is going to look for Moana and it's going to locate Moana in this data frame and find her. But another option is, instead of using the loc function, you can also use iloc function. So iloc function is the same as the first one, but the I in the iloc function means index. So it means you will have to count from 0, 1, 2, 3, 4. So Moana is number 4. So you're going to add here I to show that it's Moana, and then you're going to add here number 4. So when we add here number 4, it is going to give us exactly the same information as above. So it is up to you to decide which method works best for you. I mean, there is always, and I'm sure somebody else has another approach. So you can decide which one you want. Now, we have seen that we can access Moana as an instance, all the information about Moana. But, okay, and we have also seen that we can access savings. So in short, it means here. But then, how can we access savings for Moana alone? Because what we have done so far is get all the savings and for this specific instance. So that is going to be done using this very simple code. So we can create a variable called Moana income. And when we assign the value, we can say now, because we know it is Moana, and we have defined Moana up here as Moana is this element in the fourth index, then we can easily get their annual income, and that is from here. So that is going to be, so it is 70 grand, and you can see it right here. So the first thing is we had to access the instance first, which was done using this code. Then we went the next step to access the column. So it means that if you have already guessed that, you can easily collapse this, but I don't recommend that at this stage because it is going to create more chaos. Because we know this is the fourth instance, we can very easily have this and put this here and say we can create this as inc and have inc here. So if we run, we can very easily get the fourth row. So we can very easily get the fourth index annual income column. Or still on the same note, we had already seen this, we can very easily define it using the exact name. So I'll just copy and then come paste. Instead of this, then I will paste it here and now remove I and have just lock. So if I run that, I'm still going to get the same exact answer. Now, I want to perform another action. So let's pull our data. It was financial records. So I'm pulling this data because I want you to be seeing it as we go. So here we can also get the summary record. So for example, how many people are employed, how many people are not employed, and how many people work part-time or full-time. You're going to use the group by command or function, right? And now let me do this. I'll run this so that it can be easy to explain. So this function here, group by, is going to look at this data, right? Then it's going to look for this variable called employment status. Then create 3 groups based on the information that is available in the employment status. So if it finds the first full-time, it creates this instance here called full-time. Then it says now I found the first one. If it finds the second one, instead of creating another one, it adds, so it becomes 2. When it continues, it finds the third one, it adds, it becomes 3. So it's going to do that all through your data set, right? So here, it looked and found, throughout the data set, it only found 3 items. Then now, so as it goes down, then it gets to this point. So here, it has already found 1 full-time, 2nd full-time. But when it gets here, this is not full-time. So it creates another one called self-employment. Then it assigns that value 1. When it comes next here, it realizes it had already created full-time. So it is just going to add from 2, it's going to add so that they become 3. Then when it gets here, it realizes there isn't anything. So it's going to create another instance called part-time. Then now this is going to be the summary of information about the employment status, where now you can say we have X number of people who are employed and Y number of people who are not employed. Now, given that we already know this is how it works, we want to see, for example, which employment status has the highest total savings. Here I'm talking about total savings. So we can use the same group by, but instead of using the size here, we are using sum. So when you use sum, it is going to group employment status, right? That is the variable that we want to group. But now it is going to sum the annual income. So it is going to create a groups of employment status. So that's the groups are full-time, part-time, and self-employed. Then everything that has full-time, add it. Everything that has part-time, add it. Everything that has self-employed, add it. So when we try to do that, we are going to find that all the people who are working full-time, all of them in the dataset are going to have £221,000. Okay, I don't know, whatever currency. And then the self-employed will have 98,000. These are the basics you need. Come a long way, and now you are starting to see how data is analyzed. The question is, and I mentioned this way earlier, do we really need to be inputting our data like this? The answer is no, and the big answer is no, because you have to find an efficient way. Once you've done everything, Pandas allows you to save data. Now, this data is going to be saved into CSV, and I think I already talked about CSV when we were talking about file types. Now, here we want, as you can see right now, we had created TXT files, but now I want us to create a financial records data, and it's going to store this information here, so that next time we want to use it, and we are going to use it in our next project, we can very easily pull the data from our PC. We are going to access the name of the data frame, which is called financial records. Then we are going to assign to CSV because we want to save to CSV. Then in here is the file that you want to save, the name of the file. So it's going to be called financial records in this case, but you can call it my data. But always remember, in future it is going to be called my data, so that when I will come to that section, you don't struggle with it. Now, after you've saved it as my data, you need to label that data with the right index. So the index label here is going to be name. And you can remember very well that we created a list called names, and that list was here. So this is going to be our index labels. And it is exactly the same thing that has happened right here. Okay, so we are going to assign it as index labels. And then now that we have done all this, okay, we don't need this code. Then we can run this. Now run this, and we have saved our CSV file, and it is going to be right here. The CSV file is called financial records, and it's right here. In future, we are going to do what we call read CSV. So once we read this CSV and we specify just exactly the same way it was here, that the financial records.csv is what we want to read, and always remember to put this extension in the right way. Then after that, you can now specify the index as call name. If you want to pull this data, now you can run this, and you are going to have your data. This part here pulls the data, and this shows us the data that we had saved. And this is exactly what we had saved. Among many other things, Numpy is known for array manipulation. But Numpy can also perform many other tasks. So here we are just going to focus on array manipulation because we want to be able to work with our datasets. Then later, as we go, we can learn other functions. For example, how we can generate random numbers using Numpy. So let's look at our original dataset. And this dataset, I'm going to read it into our data frame here using the data1. Remember, we saved this dataset previously. So if you have been following this course as it is, then you know we have this data up there. So when we run this, we are going to find that our data looks like this. Now, we would like to get data out of this in 3 different formats that we already know, so that we can now discuss how we can get arrays out of those datasets. So we said, 1, you can get a series. This is how a series looks like. Now, you can also create a list from this variable here called age. So here, you can extract the age variable and create a list. So we are going to call this list age list. Here, we say age is the series. The list is going to be called age list. And then finally, we have a tuple. So in this case, we're going to call it the age tuple. Given these 3 datasets, you can actually create an array from each of them. And I wanted to show you this because I don't know the kind of data that you will encounter in future. So just know that you can create an array from a series, from a list, or a tuple. Now, an array does not look any much different from this one, except that it actually works way faster than a list. And that's why when you are working with programs that need speed, then it means you're going to have to use arrays to manipulate your data. So it is going to be quicker. Now, before we can start manipulating data using Numpy, I said the first thing that we always need to do is to install the package. And now this is going to be pip install Numpy. So when we run this, we are going to have Numpy installed. But in most cases, Numpy usually comes pre-installed in Python. So this was already there. Now, once we have Numpy installed, we can import Numpy as np. We said this is the library that we are importing, but we want to give it an alias name so that we can always use the short form. Now, we are going to look at single dimensional arrays first and how to work with single dimensional arrays. So we had already defined our different datasets here. So we have this here is a series, we have this is a list, and this is a tuple. If, for example, you want to convert a series, so this series, into an array, the only thing you're going to do is you're going to pass the argument np.array, then open the bracket, and now you're going to pass your data. So like if we check, this is going to access this data here. So to convert this to an array, you are simply going to have to use np.array. If we run this, so we have an array called age array. We can also convert a tuple to an array. So the only thing we can do is to just use the np.array, then pass the name of the tuple. So we have our array here called age tuple array. So for two-dimensional arrays, so first let's create a data frame of age, savings, and credit score from this data. So when we get to run this, we have this is our data frame and we have age, savings, credit score. Now we are going to save an array containing only age into age array. Then we are also going to save another array containing savings into savings array. And the third is going to be for credit score. So when we run this, we have the age array contains the age 34, 29, 41, 37, 31. So this column here. Then we also have the savings array. And finally, we have the credit score array. So these ones here are called single dimensional arrays. You can now create a two-dimensional arrays by simply having an array containing arrays. So what do I mean? So when we get to run this, we get this array here. This array is exactly the same as this array. If you look at it keenly, if you have done some bit of math, you're going to see like this is raised to power 1, e raised to power 1, so it means this is 34. To power 1 means this is 29. So simply, this array, what you're seeing here, is exactly what we have here as 2D array. So it is this one here, right? So these two mean the same thing. Now, the first thing that we are going to deal with in arrays is called indexing. To do that, we will take our age array. So we defined the age array up here, that the age array contains information about age. So we'll take this age array, and now we want to access an element. So we're going to define this as our one-dimensional array right here. And then we're going to try to access the first element. We said Python counts from 0. So if you want the first element here, you're going to input this. So when you pass this and try to run that, you're going to get 34. If we check the second array, then we get that the first element was going to be 34, 29, 41, 37, 31. Why? Because this here is a two-dimensional array. And a two-dimensional array, as I said, is an array made up of arrays. So this is going to be our first element, then this is going to be our second element, and then this is going to be our third element, in that case, the array. So if you want, for example, to access an array within this array, then you will have to specify this as 0. So when you get, you're going to get like, for example, this is the first instance in the first array, and that is going to be 34. Exactly the same thing here. But now, to get the first array in a two-dimensional array, it contains this all information. So a 2D is simply an array of arrays. Then we can also pass this and see the kind of data that we have. So this is an array, as you can see here, and you can also access the last element just the same way we did with lists and many other data types before. To access elements from the left, you simply start counting -1, -2, -3, all through to the first one. So if we say -1, this means we're actually taking this last element. So when we get to run this, we get that the -1 is actually 31, this last element. Good. Now, what is slicing? Slicing, we said, is accessing a part of an array. And the same way we did with lists, you can also slice an array. So when you want to slice, for example, you can only get to access these first 3 elements. Or you can access from here all through to the last element. Or you can access only these 2 elements. So slicing does the same way as it was done with lists earlier before. And how are you going to do that? So when we use this slicing here, it's going to access the first 3 elements from the left. So if we run this, you're going to get the first element is 34, 29, 41. You can also access an element from the index 2 through 5, and that is going to be 0, 1, 2. So it's going to begin from 2 through 5 up to this point. And that is simply, you're going to pass this. So this means you're going to pass from 2 up to index 5. And when we get to run that, we get actually it's from 41, 37 to 31. Now, another way of accessing an array is you can get to access the first element where you're going to start, but now you can specify where you're going to stop from the right side. So this means, for example, we are going to begin from index 1. This is index 1. And then we will stop at -1. So this is -1, right? So when we get to run this, it is going to be 29, 41, 37. So it means 29, 41, 37. So we stopped here. It means we excluded that and we excluded this one here. And now you can also, of course, get to change this, for example, to 2 and such. Now, what if you are given an array and you want to order the elements of the array from the smallest to the largest? You're going to use the command called sort. So sort is going to arrange these elements from the smallest here, we know, to the largest, which is 41. And now when we get to sort that, we get this as our new array: 29, 31, 34, 37, 41. So if you want to know maybe if this is an increasing order or a decreasing order and how this can be manipulated, so you can simply use the np.sort command in Numpy. Now, another key command is going to be the shape. It's going to tell you if the array you are working with is a 1-dimensional or a 2-dimensional array. So if we run, for example, 1d array.shape, we already know this is a 1-dimensional, but when we get to run, it tells us 5, so it means this is a 1-dimensional array. A 2-dimensional array is going to have these 2, 5, 3, 5. So we have 3 arrays, and then each of those arrays has 5 elements. Okay. Now, can we, for instance, take this array? So we said this has 3 elements. So this is 1, this is 2, this is 3. Can we change this into a 1-dimensional array? So that one can be done using the reshape function. And the reshape function is going to create a new array, and we are going now to try this. First, before you even start working on the reshape function, you need to know that when you are creating an n-dimensional array, for example, ours, here we had a 1-dimensional array with 5 elements, you cannot create a 2-dimensional array with a 2x2. Why? Because when you say 2x2, it means you have 2 arrays with 2 elements. So when you count, that's going to be 1, 2 for the first array, 1, 2 for the second array. So it means this element here is going to lack. And now you cannot reshape with that. So when you are reshaping, you must ensure that whichever shape you are reshaping to, it has to take care of all the elements within an array. In that case, now I will have to select or slice up to the 4th element. So I will take this first 4 and now create a new array so that we can create a 2-dimensional array. So that's what we have done here. Now, when we try to reshape this into a 2x2, this is what you get. So we have gotten a reshaped sample. And when you try to run reshaped sample, the first original array was this, but now the reshaped sample contains this first 2 and then these 2. So that is how the reshape works. But you can also take this 2-dimensional array back to a 1-dimensional array as it was originally. Then this here is what we get. And now we have an array called reshaped sample, and we can actually run this code and get the original array. Of course, we had already run this command, so you should not try to run that. So it means you can get a 2x2 array from this original array, which is a single-dimensional array. And once you get this, you can still take it back there. I'm sure there are very high chances that you're asking, but why on earth are we doing all these things? These things are important because this is how you access your data. When you're working with data frames or big data for that matter, you will only need to slice into small chunks that you need to work with. So you need to be aware of how you're going to access this data and what format the data exists in. So for example, if it exists in a list, you need to know how to access data within lists. But now in this case, it exists in arrays. And now we are trying to get familiar with the basic commands that you're going to use in working our things out. Now, you can also split an array. So let's look at this array. We can split this array into 2 arrays so that we can have this separate array and this separate array. Here, we are going to use the array split function. So we are going to run that into, this is the data that we want, reshaped sample, and we want to split it into 2. So when we run, and now we want to see what we have gotten, we have 2 arrays, this one and this one. You can also split this, for example, into 4. So here we run this, and now when we get to run this, we get 4 different arrays containing a single element. So that's how you can split. Alternatively, you can also use the np.split. So here we used np.arraySplit, but here we are using the np.split. So you can use either of these two, and now when we get to run this and try to see what we get, this is these are 2 sets of a single dimension array containing 2 elements, and you can also change this, of course, to exactly the same thing as above. And now here we have used a different function as this. So you have the option to use any of these 2. Now, after you've split all this, can you then join them back? The answer is yes. So let's look at the split sample that we have. So we have the split sample here. So we are going to change this, for example, to 2. And then we can get this array containing this and this. And we are going to call this split sample. Then we are also going to change this to 2. And now when we run this, we also get exactly same thing, right? So if we want to join these 2 arrays, so we have the first array as 3429, this first one. And then we have the second array as 4137. So to join them, you're simply going to use np.concatenate. And now when you concatenate these 2, we are back to our original dataset. So it means you can perform this specific manipulation after you've split. You can join back using the concatenate function. The final thing, and this part here usually confuses a lot of people. There is something called copying and viewing array, and those are commands. So when you have an array like this one here, but you want to manipulate that array without changing the original array, you're going to use something we call the copy function. So when you use this, it is going to create a copy that is independent of the original file. So let's do an example. So we have this 1D array, which is this one, and we want to create a copy. So when we do that and we run this, we get a copy which looks exactly like this. Now we want to perform some manipulations on the copy and see if these manipulations are going to affect the original instance, which is 1D array. So we are going to add this number here so that we can easily see it. And this is going to replace 34 because it's at index 0. So if we run this, we will get two arrays, the first one and the second one. Why? Because we changed 1D copy. So every time you make a change to the new copied array, it does not affect the original array. This might look obvious, but you need to be very careful and you need to remember this because the view is going to behave differently. Again, if you make changes to the original array, it is not going to affect the copied array. And we are going to do that by running this cell here so that we can, instead of having this changed one, we can actually run back to the original. So we have this our 1D array, right? So we want now to change the 1D array and see if we are going to get a different array from the one that was copied. So once we see that, we are going first to copy the array. So we are going to create an array called 1D copy. And when we do that, we had already seen that we'll get exactly this same array. But now we want to change the original array and add this. Up here, we changed the copied array, and so that changing a copied array does not change anything with the original array. So it's the same thing here that we want to try and see, and there is no change to the original array if you change to the copy or the other way around. So it means, in short, whenever you see the dot copy, you're going to create two arrays that are going to be manipulated and are going to behave completely differently. Now, there's the view, and this behaves differently. So it is going to pass the information or details contained in this array. But now how it is going to be manipulated and the effect it's going to have is different. For example, when we take our 1D array here, we already know what this is, and we create a new array using the view function, we are definitely going to get the new array. But if we try and change this view array, this array that was created with 8888 and run, you will realize that both are going to change. So it means the original array is not independent of the new array which was created. Anything that you do with the new array affects the original array. And this can also be repeated. So we have now this array, remember? So this can also be demonstrated that when you change the other array, so let's do this. Instead of having 88, let's change the 1D view because both look the same at this stage. Let's change one of them to 333 and then see if there is going to be a difference. So when we try to change that, and we are going to realize that we are also going to get this different. So the only message that you should get from this is that whenever you're using view, the created array and the original array are going to behave similarly. Whenever you make a manipulation on one, it affects the other one. But when you create a new array using copy, they are going to behave independently such that whatever you do with the first array does not affect the second array. And I hope that is something that now makes sense to you. In analytics, there is a unique way that you are supposed to think and see things in the world. For example, if you look at an image, when you see a cat on an image, your PC is not going to understand that as a cat, but you're going to have to present that in an array format so that it can be analyzed and it can be identified. A lot of things, other things like the sound that you are hearing, the video that you are watching, anything can be converted into an array containing numbers. Now, what you are looking at here is an array containing client data. And this is mostly how you are going to see your data, especially in the financial sector. So you have this array, and this is going to be called a two-dimensional array. So a two-dimensional array, it means we have this dimension and we have this dimension. But then, what does an array contain? Now, in classical statistics, you have probably heard something called variables. Here, we have this green section, and we have name, employment status, age, occupation, annual income, savings, and credit score, and these are going to be called our variables. So, we can extract an array containing variables only. What do I mean? So I said this here is an array. But if we take this part alone, we also get an array. So this is an array, and this array contains variable names only. In future, when we will be doing our machine learning projects, you learn that you may not need to use all variables to train your model. So if you take a small sample of these variables, for example, if you only take age, occupation, and savings, and use that to train your model, we are going to call these features. So you need to start getting familiar with that kind of naming. Then you notice there's also different rows here that we have, and they have unique client names. In normal practice, people will always use things like client ID. So there are unique identifiers that when you see that identifier, you will only know it is Wei Chen and Wei Chen alone. So this one here is called observations. So we can call these observations or instances. So we have an observation for Wei Chen. Now, a question would be, can you access specific information about Wei Chen based on this array? For instance, how much has Wei Chen saved? So that means you're going to take the client name is Wei Chen and come and check under savings. So you're going to have this as they're saving 12 grand. Now you need to start training your mind to see things in that format, so that every time you want to manipulate your data, every time you want to run your model, every time you want to code, you're going to have this mental picture of how your data is going to look like when you are writing instructions. But then, as you have already noticed, this one here is vertical and this is horizontal. So it didn't mean that we were going to have to write an horizontal array. So it means you can easily extract that information and input it in this format. An array can contain different data types. We have already talked about data types. So, for example, this one here is text. This one here is numerical. And this one here is float. So it means this array contains information that is of mixed data types. And there are things you can do and that you cannot do with this kind of an array. So if you don't remember what we talked about in the array section, just stop here, go back and look at information about arrays, how to transpose, how to slice, how to arrange and rearrange, and append and extend. Then you can also have an array that contains pure information belonging to one specific data type. For instance, we have this array here and it contains information which is in numerical format. So this is information about age. So for example, if you wanted to access this, then it means if we called our data, for example, D, then it means you're going to say D, age, and then it is going to give you this. We are going to write a code about that. But now, there is something else that you have probably heard in mathematics and every other discipline where we are going to use this kind of numbers. You have probably heard about something called a matrix. and you have also had something called a vector. This array can also be presented in terms of a matrix or a vector. For example, a matrix is something that looks like this. So it contains information here. Then we also have a vector, which is going to contain, for example, we can input this information about age in terms of a vector, and that is going to be this vector. So this vector is going to be 34. Sorry, does not have this comma. So this is a vector 34, 29, 41, 37, 31. So you need to try and start seeing things in this format. For now, this is all you need to know, so that when I will be telling you we need to access information about Sophia, and this information is going to be their credit score, then you know we are going to have to access a feature called credit score for an instance called Sophia. Now that you know all this, we are finally to the ultimate part of this course. And before I leave this exercise to you, and of course I'm going to leave the answer to this question, I would like to congratulate you, because getting this far is not easy. It needs resilience and dedication. And as you've seen, actually manipulating data in Python is not complex. Because I've been working on machine learning research for quite some time now, I think we tend to overemphasize or overestimate how difficult machine learning can be. It is complicated. I don't want to lie to you. But if you are trained and you are taught in the right way, I think it is easy for somebody who is dedicated enough to learn and understand. So in the near future, I will be extending these courses to discuss machine learning, deep learning, and more importantly, the ultimate part of it, which is called explainable machine learning. That is actually what I've been working on. So here I have a question for you, and you're going to read this question very carefully. You have already seen the data. This is the financial records data that we have been working on all through. So you're going to go through that data and try to understand it. Then after you've done that, you will look into this question. So you can pause here, read the question carefully and understand. I would recommend you try not to use AI at this stage to answer your questions. But of course, in future, when you're doing your coding, I will advise you to continue using it as long as you understand what you're doing exactly. So because you're learning at the moment, try first to write your codes and think through your questions and think through your logic, then answer this question. So I've broken it down into 7 steps, but of course, in a real working environment, nobody's going to write it down for you. You're going to have to write down these rules for yourself before you start solving your question. Or you can have a mental map of it, whichever you choose or whichever way you choose to work. Now, once you have answered this question, I'd like you to leave a comment containing your code. You can either take a snip of your code and leave it, or sometimes because the snip might be too long, you can actually copy the entire code and leave it in the comment section. So people who have worked through the project and have seen actually what you have done so far can go through it and try to see the logic that you used. There are so many ways that this question can be answered, and I'm sure everybody is going to have their own unique approach. So no answer is going to be better than the other one. But of course, we have more optimum codes than others. So it means at this stage, you should not be worried about that. But we have codes that work better, quicker, and faster than others. And also those that have taken the right logic, in the sense that if something small changes, actually the code will still continue working without breaking. After that, now you can come down here and check the answer that I've actually left for you. So I did not leave the code, I've left you the solution. I have done the coding myself, and then after that, I have saved my solution, as you can see here. So I expect you to have this table at the end of your coding. However you choose to do it, you should have the table containing risk profile and loan limit, and they should read as follows: moderate, invalid, low, moderate, high. And then these are the loan limit values for all these people. You can actually pause here and then go back here and check if this logic is met in this solution. So if you get an answer like this, congratulations. But wherever you get stuck, just let me know. Leave a comment and then we can pick it up from there. I will always try to respond to your comments so that we can learn together. So I'll see you on the next one, which is going to be data structures and algorithms, then before we can now start working on the real machine learning projects. Congratulations, and please remember to subscribe. Bye bye.